panda, 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 panda. I got broads in Atlanta, just to the lean the family. Credit cards in the scammers, hitting the licks in the van.
Hello guys, welcome to AWS Certified Solution Architect Associate course. So my name is Saurabh Singh and I am a certified AWS Solution Architect. So in this course we will basically discuss all the course curriculum in stepwise manner. So without wasting time, let's continue. So first of all, here we want to discuss about cloud history. So basically AWS is internally launched in 2002 for first time for Amazon.com, and at the time of 2003 Amazon developed a huge infrastructure like more than hundreds of services, and these services, Amazon infrastructure is one of their core strength idea to market. But at 2003 none of the services is launched publicly. So first time in 2004 Amazon Simple Queue service is launched publicly, only one service, which name is Simple Queue service. But after 2 years, in 2006, Amazon relaunched the SQS S3 and Elastic Compute Cloud publicly, and in 2007 it's launched in all the Europe countries. So some of the biggest AWS basically consumer are Netflix, NASA, Dropbox and Airbnb. They are using the AWS services to manage their website and all computing related tasks. So let's discuss about some AWS cloud number facts. Like in 2019 AWS had $35.202 billion annual revenue, which is such a big revenue, and AWS accounts hold approximately 50% of the market in 2019, and Microsoft had second position with 22% market share, and over 1 million active users have AWS have over 1 million active users. So this is such a huge amount community of users of AWS. So let's move on next slide. So basically what is AWS cloud use cases? So basically I think we all know what is the AWS cloud use cases. So because AWS gave the on-demand and sophisticated scalable servers and applications by which we can manage our website and any computer related task. So that's why AWS cloud is so famous. So some use cases include maybe enterprises, IT, backup and storage, big data analytics, website hosting, mobile and social apps, and gaming hosting, and many more. So like here example is given Netflix. We all know, approximately everyone is using Netflix nowadays to watch movies. So basically Netflix uses the AWS services to host and manage their videos on internet. So let's talk about the AWS global infrastructure. So AWS global infrastructure is divided into AWS regions, availability zones and data centers, and each locations and point of presence. So by visiting this website we can see more about the AWS infrastructure, and I will like to give you more information about this. So basically I copy here basically we can search it on Google, AWS infrastructure. Then we can, so you have to go on second link because first one is add link. So we can see here how many regions are there and how many availability zones and many more information about AWS infrastructure may be seen here. So here 25 launched region, 81 availability zones and 11 local zones and 8 announced regions and 6 announced local zones. And basically here they gave me 2 times more regions than second largest cloud provider. Means it's talking about the who is second largest cloud provider. It is Microsoft Azure. So they show the AWS have 2 times more regions than Cloud Azure. So we can see here in this basically map how many regions are basically deployed and how many are coming soon. So these regions are already deployed, like if I am in India, so here Mumbai region is already launched and here a new region is coming soon in Hyderabad. So here are some benefits are also illustrated, like security, availability, performance, global footprint and scalability and flexibility. Like so you can see here some more infrastructure related information. Let's move on next slide. So basically it is loading because I am presenting here from internet. Okay, so let's talk about the AWS regions. AWS has region all around the world, as I show, and names can be like US East 1, US West 3 and like here many more, AF South 1 and in India, like in India there is a Mumbai Pacific region, like Asia Pacific in Mumbai, AP South 1 and most AWS services are region scoped, like they only work per region. So let's move on next slide. So how to choose, and the question is what is the means of these regions and how to choose an AWS region. So here I will like to discuss about 4 points, like compliance, proximity, available services, pricing. So first of all, if we talk about compliance, then with data governance and legal requirements, data never leaves a region without your explicit permission. Like if we are from a government body, then we like our data did not cross our region, like our data is stored in only Mumbai. Like if I am from India and I working from Indian government, then there is some rules and regulation for which we have to store our data in India. So that's why we have to choose that region to Mumbai Pacific, Asia Pacific Mumbai region. And the second one is proximity. So why proximity is important? So proximity is important because where our customer is located, like if our customer belongs from India, then we have to choose the Asia Pacific Mumbai region because Mumbai region is located in India and this overall reduced the latency. So for reducing latency, we choose the closest region which is approximated with our customer base. So and third point is to choose the region is available services, and third one is pricing. And so I think you all know what is pricing. So prices of prices of AWS services is different in different region. So if we want to choose the region with less cost, then we can choose according to our cost and our budget. So let's move on to the next slide. So what is AWS availability zone? Each region has many availability zones. Like it may be usually have 3 availability zones per region, but minimum is 2 availability zone and maximum is 6. Like if we talk about AP Southeast, it means if I talk about the AWS region Sydney AP, then here AP Southeast 2, then there is 3 availability zone: AP Southeast 2A, AP Southeast 2B, AP Southeast 2C. So each availability zone is one or more discrete data centers with redundant power and networking and connectivity. They are separate. So here point may be noted. They are separate from each other so that they are isolated from disaster. So this is for the data recovery purposes. Like if one of our availability zone goes down, like if flood is come or any physical disaster come and affect one availability zone, like if here affect AP Southeast 2C, then it does not affect the services of AP Southeast 2B. They are connected with high bandwidth ultra low latency network. These all availability zones are connected with ultra low latency networking. So what is AWS points of presence? So point of presence is also known as edge locations. So as here these points of presence and edge locations number may be differed from time to time. Like this data is written here at 10/4/2021. So at this time, Amazon has 260 point of presence and 205 edge location and 11 regional caches in 84 cities across 42 countries. But some are, as we know, some are in under construction. So you can check the latest number on the AWS infrastructure global infrastructure page. So content is delivered to end users with lower latency. What is the purpose of its location? So main purpose of its location is content is delivered to end user with lower latency. So let's tour of the AWS console. AWS has global services. Like some global services are like IAM, Identity and Access Management, Route 53, DNS services, CloudFront like CDN, Content Delivery Network, and Web Application Firewall. And most of AWS services are region scoped. It means they are only worked within that region. They are applied only that region. So like Amazon EC2 infrastructure as a service, Elastic Beanstalk platform as a service, Lambda function as a service, and also this time Lambda may be termed as a code as a service, but basically it is a function as a service. Recognition software as a service. So you can visit that web, this link, to grab more information about this. So let's move to first section of this course, which is most important section of this course is IAM section. IAM is stand for Identity and Access Management. So let's talk about IAM users and group. So as I say, IAM is stand for Identity and Access Management. It is a global service. It means the changes here made is applied to all over across all account. Like if it is a root user, then all those changes, all IAM services may affect the whole account. And first of all, here root account is created by default, should not be used or shared. It means root when we create a AWS account, then default account is known as root account. Users are people within your organization and can be grouped. And groups only contains users, not other groups. Users don't have to belong to a group, and users can belong to multiple groups. So here an example is given, like group of here is a group developer and group audit team and group operation. So here Charles belongs from two groups, like developers group and audit team group, and also David belongs from two groups, operation group and audit team group, and Fred is a standalone user. So let's move on next slide. So here basically this slide is blurred. So here we talk about the IAM permissions. So how to control IAM permission? Users or groups can be assigned JSON document called policies. So here if you are able to see, here a policy is written here. So in AWS we supply the least privilege principle. We follow the we apply the least privilege principle. So we don't give the more permission than a user required or need. So basically all IAM permission is granted in form of some policies, and these are the JSON documents. So what is IAM policy inheritance? So IAM policy inheritance is if we give some permission to developer, like if Charles is a member of developers group and Charles have some policy assigned to Charles, and Charles is also a member of audit team, then here what will be happen? Basically here if in developer group some policies assigned to Charles, then Charles inherit those properties, and Charles also have properties assigned in audit team, like David. Here if David belongs from audit team and it's also belongs from operation team, then David inherit the properties of audit team and also from operation team. So and here Fred is inheriting her assigned policies. So let's move on next slide. So what is the basic structure of IAM policy? So IAM policy consists of a version section which have policy language version always include 2012-10-17, and ID is an identifier for the policy which is an optional section, and statement is the required section and can contain one or more individual statements. And what is these statements? So most important section of IAM policy is these statements. So first of all, first attribute of statement is statement ID, which is also an identifier of the statement, which is also a optional section. Effect: whether the statement allows or denies access, like this policy basically this statement is going to allow or deny some permissions. And what is principal? Principal is like a count, user or role to which this policy is applied. It means principal is something on which this policy is going to affect. Action: list of action this policy allows or denies. Here action section is here. And resource: list of resources to which the action is applied to. Condition for when this policy is in effect. It is also an optional section. So here a snapshot of a sample policy is given here. So here version is given as a version is a static element. So and also it is an optional. No, version is a basically a required field, and the optional field is ID. So basically here S3 account this policy is related to S3 account permission. And what is statement section content? Basically statement section content first of one statement ID, and then what is the effect of this statement. So basically this is a allow statement, effect is allow, and principal on which basically users are on which role, on which account this policy is going to affect. So this is a basically a root account user on which this policy is going to affect. So next one is what action are basically on which action this effect may be applied. It's going to apply it. Basically this is S3 get object and S3 put object. So here we are giving permission to we are allowing permission to this account to getting sub object and putting sub object in S3. What is the resource? So resource is basically a S3 bucket. So this is all about the IAM policy structure. This is basically a JSON document as I discussed previously. So let's move on next slide. What is IAM password policy? So IAM password policy may be assigned to users or role or to complete account. So like if we require a strong password, so strong password is equal to higher security for your account. So always make a strong password policy. So in AWS we can set up a password policy, like we can set a minimum password length, like password must be of 8 character or 10 character or 10 digit, something else, or require specific character types, like it must be include or must be avoid uppercase letter, lowercase letters, number and non-alphanumeric characters, and allow all IAM users to change their own password. So there are many features of password policy. Overall we can control all these related tasks by changing the password policy. So let's move on next slide. So what is MFA? Basically, we in this era we all are concerning about security. So what is the solution of this generation? Is solution is MFA, multi-factor authentication. Like Google is using multi-factor authentication, and nowadays every modern website and every modern basically service provider is giving option to activate multi-factor authentication. So what is basically multi-factor authentication? I think we all know about it, but here I give some demo. Like if Alice is a user and he provide her password plus MFA for a successful login. Like in second generation website, we only required a username and password to log in on any website. But in this era, we must have a user ID, password, and if we activate MFA, then here is a MFA key is also a required element for successful login. So we cannot log in without this MFA key. So MFA may be activated with some software device or hardware devices. So main benefit of MFA is if a password is stolen or hacked by a hacker, account is not compromised, because hacker can hack only password, not the MFA keys. But some situation may be arises, you hacker may also impersonate your MFA keys. Like hacker get your mobile phone access and they request the both MFA keys, either it is form of software MFA or in the form of hardware MFA. Like if we are using the Google account and someone hacked our password and also they thieves our mobile, and mobile does not have a screen lock, then what is going to happen? They already hacked our password and they know our username. So first of all they log in by using username and password, and when MFA is come to your mobile phone, either it is a hardware MFA or it is a form of some third-party tools like Authy and two-factor authentication softwares. So they can get both password and MFA for a successful login. So here you also have to take care of these MFA keys. Okay, so let's move on next slide. So what are the options present in MFA devices option in AWS? So virtual MFA devices like Google Authenticator, Authy, and two-factor authentication. These are the some basically tools which are providing the virtual MFA or software MFA. And we have also an option of universal second factor authentication like security key, like YubiKey by Yubico. It support for multiple root and IAM users using a single security key. So let's move on next slide. So what are the MFA devices option? So basically we have hardware and software, both type of MFA options, and these are some are discussed here. So how can user access AWS? To access AWS you have three options: AWS Management Console protected by password and MFA key, and AWS Command Line Interface, and AWS Software Developer Kit. So these are the three main options to access our AWS account. So access key are generated through the AWS console and user manage their own access key. Access key are sacred, just like a password. Don't share them because everyone can access your account if you share them publicly. Access key contain access key ID and secret access key like a password. So here is a example is given of access key like access key ID and secret access key. This is just a dummy access key, so it don't able to benefit you to access someone account. And what is AWS CLI? So AWS CLI is a tool that enables you to interact with AWS services using commands in your command line shell. So direct access to the public API of AWS services, and you can develop a script to manage your resources. It is a open source. AWS CLI is a open source tool. So you can use alternatively to have Amazon Web Services Management Console. This is an alternate solution. And what is AWS SDK? AWS Software Development Kit. So this is a language specific API, contains set of libraries, enables you to access and manage AWS services programmatically, embedded within your application, and support SDK like languages like JavaScript, Python, PHP, .NET, Ruby, Java, Go, Node.js, and C++. And it have also mobile SDK like Android, iOS, and many more, and IoT devices SDK like Embedded C, Arduino, and many more. Example is AWS CLI is built on AWS SDK for Python. So AWS CLI is developed with AWS SDK for Python. So what is IAM roles for services? So some AWS services will need to perform action on your behalf. So to do so, we will assign permission to AWS services with IAM roles. So common roles are EC2 instances role, Lambda function roles, roles for cloud formation. So here is an example is given. Our EC2 instance has assigned IAM role to access some AWS services. So this is all about IAM roles. So IAM roles are basically assigned to perform some specific action on some AWS resources. So what are the IAM security tools? IAM credentials report account level security tool, and IAM access advisor. It is a user level. So if you are a root user, then you can use IAM credentials report tool to manage your whole account IAM security. And if you are some user assigned with some some policy, then you can access IAM access advisor. You can use this information to revise your policies, which you are basically assigned to anyone, like to assign to any users or many more. So what are the IAM guidelines and best practices? So don't use the root account except for AWS account setup. First of all, this is a very important point. So what is the point? Don't use the root account except for AWS account setup. And second one is one physical user is one AWS user. So no user may be belong, no user contains, no physical users contains the two AWS user account. So assign users to group and assign permissions to group. So what is the meaning of this line? So we have to only assign users in a group, and we have to assign some permission to that group in which users belong. Like if we create an admin users group and we embed basically 2 or 3 users in that group, so we have to assign that permission to only that admin group. So and next one is create a strong password policy and use and enforce the use of multi-factor authentication. And next one is create and use roles for giving permission to AWS services. Use access key for programmatic access like CLI and SDK, command line interface and software developer kit. And audit permissions of user account with IAM credentials report. And never share IAM users and access key. So what is the next? Next is shared responsibility model of IAM. So what are the basic responsibilities of AWS? So AWS responsibility is that AWS has to manage infrastructure globally and manage network security, and they have also managed configure and vulnerabilities analysis on their system and compliance validation. And what is your responsibility? Like what is our responsibility? So we have to basically create users, groups, roles, policies and management and monitoring of them, and enable MFA on all accounts to enhance our security level, and rotate all our keys often, and use IAM tools to apply appropriate permissions, and analyze access pattern and review permissions. So these are our responsibility. So here we basically make a small summary of IAM. So first of all, what is users? Users mapped to a physical user has a password for AWS console. It means if my name is Saurabh Singh and if I exist physically, then we must have only one user account. And groups. Groups may contain users only. Group can contain only users. Policies. What are policies? Basically, policy is a JSON document that outlines permissions for users or group. So this policy may be assigned to users or groups, and also to assign some roles. Roles. What is roles? Roles for EC2 instance or AWS services. So basically, what is roles is assigned to any AWS services to get access of any other AWS services on behalf of this role. So what is security? Like security, if you talk about security, then think about the MFA plus password policy. Like we have to enhance our security, then we have to rotate our keys by using IAM, KMS and many more. So access key. So access key or access AWS using the CLI or SDK. So access key is used to access AWS using the command line interface or software developer kit. So audit. What is auditing? So IAM credentials report and IAM access advisor is used to audit it. So let's some hands-on on IAM. So for completing this tutorial, I already think you have a account. If you don't have account, then you can search on here on Google Amazon console and here you can make a basically account. So if you have any account, then you can sign in directly. If you don't have any account, then you can sign up. So here we can search for Amazon sign up if you don't have any account. And in this complete course we are going to use basically Amazon free tier. So Amazon AWS sign up. So here we get 1 year basically access of free tier AWS. So here we can we can click on create a free account and you can proceed on next steps. So here you can complete your sign up and by using this link. So I gave this link in my description box. So I already created my account to save some time for you. So let's log in my account. So here we click sign into the console. So here I basically log in our console, but this is my IAM account. So basically here I sign out from here. So if I click log back in, then here two options is present. First off, for signing in AWS, root user, and second one is IAM user. So when we create first time our account, then we have to basically log in using our root account. So I fill this and log in my account. So basically I am going to log in my root account to illustrate you what are the basically may be done with the root account. So I activated the MFA for my root account to increase my security. So let's fill here my MFA code, and it also did not any benefit to you to capture this, because this MFA code is going to replace in after 30 seconds. So here are some header. So here I am logged in my AWS console. So let's practice some hands-on IAM. So let's search here IAM, and here we are in IAM section. So here we create a user first of all. So let's click on add users, and username is also going to show up MCA. So here we are going to use password, and we are going to use custom password. So here I am using a custom password for me. You can also use auto generated password. So click on next, So here we have to set at basically if you I created first of all a admin group, so uh, we can add this user into a group. So this group have a policy assigned administrator access. So we click on next, and here we can assign a tag value. Basically tag value is assigned to search across a account, so but I am not going to use any tags here. So what is this means? The username is Saurabh MCA and AWS access type is AWS management console access with a password. Console password type is a custom and required password reject yes. Permission boundary is not set. So if we set permission boundary, then although we have assigned a admin basically access, then if a root user set some permission boundary to that IAM user, then he can only work on that boundaries assigned to that IAM user. So let's create a user. So basically we can download it in CSV format, and also we can provide email. So email address to send that. So here a link is given to log in our IAM user. So here we created, and we can copy this link to sign in. And if we don't copy this link, then we are also able to sign in. But if we copy it, then we can go to directly sign in, and we don't require any ID. So here ID is automatically copied, and here we have to give our username. So my username is Saurabh MCA and password which you set. So here I am just signing. So he says your authentication information is incorrect. So let's try one more time. So here we have to change our old password. So let's change our old password. So for changing old password, we have to basically enter our old password. So let's enter your old password, and here you have to enter your new password. So here I enter my new password and confirm password change. So here what happened? Here our given password are not matched. So let's try one more time. And click on confirm password change. So here our password is changed, and we are successfully logged in into our IAM user. This IAM user has assigned to basically admin access policy. So by using this manner, we can create a admin user, and here we can also use IAM. So let's begin. So always remember, don't use your root account to play with services. because root account have many of the permissions which may disrupt your whole account and may affect your services adversely. So here we don't set a MFA for ourselves for this IAM account. So here we can click on add MFA if you want to set a multi-factor authentication. So here what are the options are present. So basically here many of the options are present, like we can, if we want to assign a MFA device, then we have to click on here, and here are three options are present. Virtual MFA device, like if you want to use some authenticator app installed on mobile or device on your computer, or if you want to use YubiKey or other compliant UTF devices, and if you want to use other hardware MFA devices like Gmail token. Here I want to use only authentication app installed my mobile phone. So let's click on continue, and here we have to basically scan this QR code in our two-factor authentication app. So let's here scan my QR code, and here we have to enter these two codes which are basically given in your app. And click on assign MFA. So here MFA is assigned, successfully assigned to my virtual device. So you can close on it. So here if we go on our user section, then our this user has a multi-factor authentication, which is a type of virtual multi-factor authentication. So here you have to remember, as per solution architect perspective, we have three options to set MFA. You can choose any one as per scenario basis. Here we can also create a roles, and for this time I don't want to create a role, and here we can set see policies, and we can assign, and we can also create policy, and here are some most widely used policies are also pre-built for ourselves. And here we can go on our account setting to basically be aware these all settings are only going to apply this account, because this is not a root account. But if you are using a root account, then these all settings are going to apply to across all your accounts users. So here we can change our password policy, and we can create a new password policy. So here password policy is set with the minimum password length is 8 and include a minimum of 3 of the following mix of character types, and must not be identical to your AWS account name or email address. So basically a simple password is set, and here also a security token service is also maybe assigned. So these all options are present here, and you can play with these all options and move. I am going to move further, because if I want to discuss every point present in this IAM section, then this is going to take much of time. So here you can also set service control policy. Basically, what is service control policy? If you want to know about it, then you can go on here. Basically, you can set only service control policy if you have used organization in your AWS account. So I am not using any organization. We see it in later in this course, but until I am not using the organization, so this option is not showing for me. So by using service control policy, we can control the services who can access that service and who does not have access that service. So by using this SCP, we can control that. So let's move to our next section. So basically I have to drink so let's discuss about EC2 basics. So EC2 is the one of the most important service of AWS. So EC2 is basically stand for Elastic Compute Cloud. And so first of all, let's discuss some point about Amazon EC2. So EC2 is the one of the most popular offering by AWS, and as I said, EC2 is stand for Elastic Compute Cloud, and it is an infrastructure as a service like IaaS. It is an IaaS service, and it is mainly consist in the capability of renting virtual machines, storing data on virtual drives like EBS, distributing load across machines like Elastic Load Balancer, and scaling the services using an auto scaling groove. And knowing the EC2 fundamental to understand how the cloud works. So let's discuss about some EC2 sizing and configuration options. So basically three types of widely used operating system is also available in AWS. First one is Linux, second one is Windows, and third one is Mac operating system. And here we have to think about it, how much compute power and cores are required for our workload and how much RAM is required for workload. So and how much storage space, like if we talk about network attached, then EBS and EFS, and if we talk about hardware, the hardware storage device like EC2 instances too. So these all points must be considered during when we think about EC2 sizing and configuration. So first, just like network card for speed related tasks, and firewall rules for security purposes, like security group is known as virtual firewall of EC2, and a bootstrap script configured at first launch as termed as EC2 user data. These all points are we discuss when we are going to hands on this EC2, so don't care about it. So what is EC2 user data section? So when we are going to launch some EC2 instance, so it is possible to bootstrap our instances using an EC2 user data script. So bootstrapping means launching commands when a machine starts. So when our EC2 basically is going to start, then these all commands are launched during the launch of our EC2 instance. So EC2 user data is used to automate boot tasks such as installing updates, installing software, downloading common files from the internet, anything you can think of. So basically the EC2 user data script run with the root user. And so let's some hands-on launching an instance running Linux. So we will be launching our first virtual server using the AWS console. We will get a first high-level approach of the various parameters, and we will see that our web server is launched using EC2 user data. We will learn how to start or stop our terminate or instances. So let's move on hands-on it. So here we go on our Amazon console, and here we search about EC2. So here we have currently no instance running, so let's click on launch instances. So this is a new EC2 experience. If you close it, then UI may be different. So I am showing this on a new EC2 experience. So let's launch an instance. So here we can select any of the three tier eligible AMI. So for launching, here I select basically Amazon Linux 2 AMI with SSD. So click on select, and here I am going to use T2 micro because only T2 micro is available in Mumbai region. In your case, if region is different, then here T3 micro is also available in free tier, but here we have only T2 micro. So next click on configure instances. So here we are going to launch only one instance. If you want to launch this instance in auto scaling group, then we can select here. Either if you don't want to request spot instance, then please don't tick it. And these are the basically network. This is default VPC in which our EC2 machine is going to launch, and this is the default subnet. So we don't have to think about it, and we have to only here user data section. This is the important section. Like every section is important equally, but here by using this section we can launch some bootstrap script. So we can Google it on. So to launch some script, like if you want to launch basically Apache server in our instance during the launch time. So we can search here launch. Basically we can search here bash script to launch. PT on Amazon Linux. So we can Google it. So here we can basically click on first link because this is AWS link. So always prefer official AWS links. So I go here, and here I have seen my script. So this is the basically script. What this script is going to do, this basically update our Linux AMI, and this is going to install a lamp stack on our system. So what is lamp? Lamp is stand for Linux, Apache, MariaDB and PHP, MySQL and PHP. So basically we can use this script, either we can use any third-party script. Like if you want to use this script, then we can copy it and paste in it on our user data section. Like if you don't like this script, then we can basically search for next thing. Like if we want to echo our IP addresses of our instances, then we can search here for bash script to launch HTTPD on Amazon Linux to echo IP. So basically here are also some code may be given by any third-party website, like this is a Java course geeks website, and here we can copy these scripts basically, and we can paste it on our user section. So where is my, basically here, this is here. So we can paste it on here. You can paste as per your requirement. So I paste it here in user section. So basically this what this script do: first line is a bang line of bash script, and second one is for updating our AMI, and second one is for installing basically HTTPD, which is Apache server on x86 to 64 architecture, and second one is a system control command to start HTTPD services as a startup, and this is for enabling HTTPD services, and last one command is to echoing hello world with our IP host name, it means IP address. So we can click on next. So here we can configure our storage. By default it is 8, and we can take up to 30 GB EBS general purpose SSD. It is a GP2 volume, so 3 tiers contain 30 GB of volume. So here I set it as, so next one is add tags. You can add tags, so I don't prefer tags, so I here don't set any tags. So here we can set add rules. So as per our requirement we can set rules here. Like here I add HTTP and HTTPS, and here in configuration don't if you want to here config some more information, then we can check it. But here I am not going to assign any role to this EC2, and here this is not launching in any placement group, and no capacity is reserved, and here I don't enable hibernation. So these option can be also modified as per your requirement. Okay, so here click on next, and review and launch. So here this is giving warning, so just ignore it because we are going to dispose this AMI after this hands-on. So let's click on launch. So I already have a key pair. If you don't have any key pair, then you can create a new key pair, and you can assign a new key pair name. Like if I assign here Linux, so I assigned here Linux, and we can download key pair, and next click on launch instance. So my Linux VM is downloaded. So after clicking here we can see the view instance. So here my instance is instance state is pending, so that's why here no IP address and no configuration is available. So let's wait for 30 seconds 2 minutes to this EC2 instance up and running. So let's wait. So here my instance is in running state. So let's check about its configuration. So here our instance does not have any public IPv4 address. So why this happened? So this case may be also happen with you. So that's why I discuss here this case. तो फ्रेंड्स, जैसा कि हम लोग यहाँ पे देख पा रहे हैं कि हमें केवल और केवल प्राइवेट IPv4 एड्रेस असाइन हुआ है और यहाँ पे हमें पब्लिक IPv4 एड्रेस नहीं असाइन हुआ है। तो ऐसा क्यों है? क्या इसके पीछे कुछ रीजन है? There is any reason behind this? So here we did not assign any public address. So for that, what is the resolution? So for solving this problem, is any configuration is missing or any security group is missing? Why this we did not have any public IPv4 address assigned? So there may be many reasons to this issue. So first of all, the root case of this reason may be you are not created any public VPC. It means you did not created an internet gateway to, and you cannot attach any internet gateway to this. So here we can search for internet gateway. So here is internet gateway. Here we can see this all the internet gateway is attached. So here for seeing this, we can note down our basically VPC ID, but here I see my VPC ID is attached to internet gateway. So this is the not region. So what is missing? So here without wasting your time, I will show you what we are missed, why we did not get any public address or public IPv4 address. So first of all, we missed a configuration during our installation, not installation, during startup of our instance. So let's create a new instance and I will show you what is the problem, what is the root case behind this. So here we click on next and configure. So here first of all, you make sure you launched your instance in default VPC or in public VPC. It means you gave a public CIDR to your VPC during the creation. And second one is you have to check here is your auto assign public IP is enable or disable. So it must be enabled. So here make sure your auto assign public IP is enabled. Okay, otherwise it will not going to assign a public IPv4 address. So this is the root case behind that problem. So I want to show you this problem so that I done it purposefully. So let's install our basically Apache server by using bootstrapping. So here we can copy this script. Basically this is a bash script, and paste it in your user data field. So here I go here and paste here. So basically I explained this script, what script is going to do. Basically this is a first line is bang line, and second one is for updating our AMI, and second one is installing the Apache server, and for this line systemcity will start httpd services is for starting the services of Apache, and this is for enabling at startup, and this is for echoing our hello world and our IP address. So let's click on next, and then here make sure you add a rule of HTTP and HTTPS as you require. So here I basically add both two rule, and here click review and launch. Here I click on launch, so I acknowledge because I have a key pair from last instance, so that basically I launched this. So here click on view instances. So here only one basically, because my filter instance is only for running, so when my instance is running then only show here. So you can apply many of the more filters like affinity, image ID, and instance ID, and many more are also available. So let's wait. So here my EC2 instance is now in running condition, and see here what happened. We follow the same procedure but enabling the auto assign IP address. Here we get a public IPv4 and public IPv4 DNS. So whenever in this instance we only got only private IPv4 address, so this instance is not accessible by internet by any other. So these types are instances are also purposefully created for only communicating within our private VPC and private subnets. So here I will show you what our user data field do. So here if we click on this public IPv4 DNS, and or we can directly click on open address. So this is showing this site cannot be reached. So because this is showing because this Chrome browser is cached my previous request, so I will open it in incognito mode. So here I come in incognito mode and I paste that same, and here what we get from our server, hello world. So basically our script is about echoing the hello world and our basically IP address and basically our host name. So this is the complete host name and this is hello world from this IP. So our basically Apache server is running now and we get response from it. So make sure you enable the auto assign public IPv4 address checked during the startup. So let's SSH into our server. Here we discuss about some method about connecting from our server. So here we can directly click on connect, and here we click on EC2 instance connect. Make sure here point is remember to that only Amazon Linux 2 instance, this option is only configured for Amazon Linux 2 instance. So here if we click on connect, then we are going to connect from our server. So here we are connected from our server. So here we can execute any command, like if we want to check Apache server running status, then we can basically run command sudo systemctl status httpt.service s is missing from here. So make sure your command is right. So here we get active running status from our Apache server. So my Apache server is running here. From here we can control our server, like if we run basically ls command here, so nothing is shown, but where our configuration file are. So this configuration file and basically in httpd, so we have to locate httpd. So we can use many more of command, but this video is only for giving the introduction and launching EC2 basics. So here we did not go to in deep dive. So basically I exit from here and I will show you a second method to log into your server. So if you are using Linux, so you can SSH directly, like I am using Kali Linux. So here SSH are already installed, pre-installed. If it is not installed in your Linux operating system, host operating system, then you can install it. So here I simply copy the IP address, or you can go to here direct SSH client and copy this. If you have SSH client, you can download SSH client for Windows from SSH official website. So I will show you how to download SSH. You can download it for Windows 10, SSH client for Windows 10. So you can search it and you can download it and install it. So you can also use alternatively putty to log into your server. So because I am not using Windows 10, then I am using SSH here, SSH client, to log into my server. So here, which basically we can use our IPv4 public IPv4 address of our instance. So like if you click here and I will copy it, my public IPv4 address from here, and I paste here and I click enter. Then here I am connected from my server. So here something is missing, so because I did not use my specified key pair, so that's why this is showing me error. First of all, I have to locate the same directory. So cd downloads, and here I use ssh-i, and my key pair name is linux.pem, and here is my username, ect user, and the IP address just we copied. So this is the simple command by which here unprotected private key, bad permissions denied. So basically we are getting permission denied error. So why this will happen? Because my linux dot pam did not have basically read write execute permission, so that this error is showing. So here I basically use chmod command. Chmod, basically here you can give 400 permission or 777 permission, because I want to vanish it, so that I will give that permission. So here okay, it did not. So first of all, make sure in Linux use sudo command, and then you can use anything here. So basically I paste type my IP address here and SSH. So yes, I want to connect, so I click on yes. So here we are connected to our EC2 instance, and here we can use any command which we basically like. If you want to check the status of running status of our server, then here we can execute command sudo system. Basically sudo is used for here super user permission, systemctl system control, and I want to see status. Sorry for my bad writing. So here I will. So what this say? This says my Apache server is running, and so my Apache server is active and running. So these two methods are generally used to connect from our server. So here I will exit from my server, and let's move on next steps. So here so next we basically discuss about the EC2 instance type and storage. So before first of all, here we discuss about EC2 instance types. So we can use different types of EC2 instances that are optimized for different use cases. So for more information you can visit on that link. So AWS has some naming convention, like if we got a EC2 instance name m5.2xlog, then what it will be showing. So here m is an instance class, and 5 shows its generation. AWS improved them over time, because if m5 shows the generation and m6 is the latest generation. If you have two instances like m5.2xlog and m6.2xlog, then you may consider m6 is the latest EC2 instance generation, belongs from latest generation. And here what is 2xlog? So it is showing the size is 2 times more than xlog. So here basically EC2 instance type are general purpose, compute optimized, memory optimized, accelerated computing, storage optimized, instance features, and measuring instance performance. So So there are many types of EC2 instance. These all are used as per their requirement. So first of all, we want to discuss about the general purpose EC2 instances, because in most of the cases we use general purpose EC2 instances. So this is great for diversity of workloads such as web server or code repository and many more. It is a balance between compute, memory, networking. Okay, so in this course we will using T2 micro, which is also general purpose EC2 instance. So here a list of general purpose EC2 instances are given, and basically official definition is also given. So general purpose instance provide a balance of compute, memory and networking resources and can be used for a variety of diverse workload. So basically this contain ATM series. ATM, you can also remember ATM series. If you say any instance starting from A, T or M, then it definitely belongs from general purpose EC2 instances. So these are Mac, T4G, T3, T3A, T2, MCJ, M5, T3, M5A, M5N, M52M and M4A1. These all information can also be gathered from AWS websites. So if you are interested to learn more about it, then you can visit. So here if you talk about the compute optimized instances, then that is great for compute intensive tasks that require high performance processor like batch processing workloads, media transcoding, high performance web server and high performance computing, scientific modeling and machine learning and dedicated gaming servers. And this contains only C series of instances. So compute optimized, so you have to remember, there is a trick to remember it, only C. If you want to know this, either this instance is compute or any other belongs from any other class, then if its name is started from C, then it definitely belongs from compute optimized. And next one is memory optimized. So these are the fast performing for workloads that process large data set in memory. Like use cases may include high performance relational, non-relational databases, distributed web scale cache store, or in-memory database optimized for business intelligence, and application performing real-time processing of big unstructured data. So, and last but not least, there is a storage optimized. So these are great for storage intensive tasks that require high sequential read and write access to write data sets on local storage. So basic use cases are like high frequency online transaction processing, OLTP systems, relational and NoSQL databases, cache for in-memory databases like Redis and Memcache, and data warehousing applications and distributed file system. So these belong from DIH, ditch. You can remember it from DIH, ditch. So if any instance belong from D or I or H, then it is definitely a storage optimized instance. So here are some examples are given. So basically T2 micro is a part of AWS free tier, and up to 750 hours per month is available in free tier. So it is basically for 32 days. So we can check it on AWS official website. So let's introduce from security groups. Security groups are the fundamental of network security in AWS. They control how traffic is allowed into or out of our EC2 instances. Like from figure we can depict security group is also known as the virtual what virtual firewalls for EC2 instances, and security groups only contain allow rules. It does not contain deny rules. And one more point I like to mention here, EC2 has only inbound rules. It does not contain outbound rules because here we have only inbound allow rules, because it is stateful. If we allow any inbound traffic, then it is going to automatically allow for outbound traffic. Okay, like if we allow HTTP port 80 for inbound traffic, then HTTP port 80 outbound traffic is automatically allowed. So let's deep dive into security groups. So security groups are acting as a firewall on EC2 instances, and they regulate access to port, authorized IP ranges, IPv4 and IPv6, control of inbound traffic from other two instances, control outbound network, but here we can only set inbound traffic. So here is a figure which is depicting. So this is our computer IP address. So we authorize port 22. So only our IP address is authorized for that port. Okay. No any other computer with port 22 can be connected from our EC2 instances. So it's provide protection in this manner. So here if we authorized any IP address inbound traffic, then it does not have to, we did not, it is security, because security groups are stateful, so it automatically allow our outbound traffic for that IP address. Okay, so let's move on next slide. So what must be learned about security groups? So security group can be attached from multiple instances. Okay, you can attach it from either in only one instance, or you can attach it from multiple instances. They are locked down to a region or VPC combination. Does live outside the EC2. If traffic is blocked, the EC2 instance would not see it. It is good to maintain one separate security group for SSH access. If your application is not accessible timeout, then it is a security group issue. So here, if point is remember this point. If your application is not accessible, it give timeout error, then definitely it is a security group issue. And if your application give a connection report error, then it is an application error, or it is not launched. All inbound traffic is blocked by default, and all outbound traffic is authorized by default. Most asked question is related to security group is all inbound traffic is blocked by default, and all outbound traffic is authorized by default for a security group. Let's move on new slide. So as we discussed this, so what are the classic ports to know? So basically 22 is used for SSH login to a Linux instance, and 21 is used for FTP, and 22 is used for SFTP, and 80 is used for HTTP, and 443 is used for HTTPS, and 3389 is used for RDP, Remote Desktop Protocol, which is a login into a Windows instance. So let's summarize our SSH table. So here, if you are using SSH, then we can use a SSH client to connect from Mac host operating system and Linux hosted operating system and Windows 10 and Windows 11. So if you are using Windows 7, 8, Vista, then we are not able to use SSH client for that. And if we want to connect our Windows 7, Windows 8 or Windows Vista by using SSH, then we have to use PuTTY. So PuTTY is worked on both all version of Windows. So if you are using Windows operating system, then you can use PuTTY to connect from your EC2 instances. And EC2 instance connect is can be used on all of OS because it uses browser and SSH port to connect from our server. Let's move on next slide. So you can if you want to watch the lectures to SSH on Mac basically, and if you want to see PuTTY lectures, so you can search it on my channel, or I can give basically link in description box. So let's move on. So here are some troubleshooting steps are given. So most of the student can face this problem. If things don't work, then you can rewatch the lectures, and if you are missing something, then you can correct it, and read the troubleshoot guide and try EC2 instance connect if all the method is not worked. So basically I will how to SSH into your instance Linux or Mac OS X. So basically we can use SSH client to connect from our EC2 instance as I show it before some minutes. So let's move on next slide. So how to SSH into your EC2 instance Windows. So you can use PuTTY or SSH client if you are using Windows 10 or Windows 11. So you can use SSH client. And EC2 instance connect are only option available for Amazon Linux too. Okay, you can configure it. So EC2 instance purchasing options. So most of the basically question can be asked from EC2 instance purchasing options. So first one is on-demand instances. So on-demand instances are best for short workload and predictable pricing. And reserve is reserved instance is only can be used for minimum of 1 year or 3-year term. And reserved instances are 3 types: reserved instance which cannot be convertible, and convertible reserved instance, and scheduled reserved instance. And spot instances. So spot instances are best suitable for short workload, cheap, they are very cheap, and you can lose any time these instances because these instances are buy on some bit price. So we will discuss it more deep manner later. So let's talk about dedicated host. So we book an entire physical server and we control the instance placement and dedicated instances. So basically no other customer will share our hardware, but my account can share the instances if we buy a dedicated instance. Okay. So let's discuss about EC2 on demand. So EC2 on demand you get the server pay for what we use, and it is a Linux. If you are using Linux, then billing per second. Otherwise, if you are using Windows or any other operating system, then billing is only per hour available. So has the highest cost but no upfront payment and no long-term commitment. So recommended for short-term and uninterrupted workload where we cannot predict how the application will behave. So let's discuss about EC2 reserved instances. So we can avail up to 72% discount compared to on demand. So we can reserve it for 1 year period or we can reserve it for 3 year period. If we reserve it for 1 year period, then let's suppose we get +1 discount plus X% discount. Then if we are reserving it for 3 years, then we get 3 times more discount for reserving that instance. So purchasing options are available: no upfront, partial upfront, and all upfront. We get more discount on all upfront. So reserve. Here we reserve a specific instance type, and this type of instances is only recommended for steady state usage application like databases. Here we have 3 options. Either it is fully reserved instance, or it is convertible reserved instance, either it is scheduled reserved instance. So let's talk about spot instances. So here we can get up to 90% compared to on demand discount. So instance that you cannot lose at any point of time if your basically these types of instances can be lost. Sorry for my mistake. So this type of instances can be lost at any point of time if your max price is less than the current spot price. So the most cost efficient instance in AWS. So spot instances are most cost effective instance in AWS. These types of instances are basically useful, which workload are resilient to failures. So basically like batch jobs, data analysis, image processing, and distributed workloads. And these types of instance is not suitable for critical job or databases. So EC2 dedicated basically host, not instance. EC2 dedicated host is used for basically reserving a physical server with EC2 instances capacity fully dedicated to our use. So dedicated host can help you address compliance requirement and reduce cost by allowing you to use our existing server bound software licenses. So allocated for our account for a 3-year period reservation. So minimum these dedicated hosts are only allocated for 3-year period reservation. This is more expensive than other types of instances. So because here we are basically buying a physical server. That's why this is most expensive. So this is useful for software that have complicated licensing model. Bring your own license model, or for companies that have strong regulatory or compliance needs. So EC2 dedicated instance. Don't mess with EC2 dedicated host and dedicated instance. Both are different. Me also sometimes messed with these two topics. So here make it clear, EC2 dedicated instance and EC2 dedicated host both are different. So always remember, EC2 host dedicated host and EC2 dedicated instance both are different. So when we are talking about EC2 dedicated instance, then we are talking about the instances running our hardware that is dedicated to ourselves. So it may share hardware with other instances in same account. No control over instance placement. Okay. So here some difference between dedicated instances and dedicated host are discussed here. So enable the use of dedicated physical servers, both dedicated instances and dedicated hosts. Per instance billing subject to $2 per region fee only for dedicated instances. Per host billing only for dedicated hosted. Visibility of sockets core host ID only for dedicated hosts. And affinity between the host and the instances only for dedicated host. Target instance placement can be only set in dedicated host. And automatic instance placement may be done on dedicated instance or in dedicated host. So add capacity using an allocation request can be only we have only option in dedicated host. So let's move further. So here how we can decide which purchasing option is right for me. So here's points we can take here example of a resort. So on demand. What is on demand? When coming and staying in a resort, whenever we like, we pay the full price. And what is about resort? We like planning ahead, and if we plan to stay for a long time, we may get a good discount. And here, what is about spot instances? They are like hotel allows people to bid for the empty rooms, and the highest bidder keeps the room. You can get kicked out at any time if someone bids more price than you. What is dedicated host? Will book an entire building or the resort. Okay, no one can buy there. So here is a price comparison chart is given for M4 large and US East 1 region. So we can say it. Let's move further. So what is the EC2 spot instance requests? So we can get discount up to 90% compared to on demand. So define max spot price and get the instance while current spot price is less than max. So here we define a maximum spot price, and if spot price is less than max, then so like spot price is basically $2 and we set a max of $4, then here spot price is less, so we can get that instance. The hourly spot prices varies based on offer and capacity. if If the current spot price is greater than your max price, we can choose to stop or terminate our instances with a 2-minute grace period. Other strategy is spot block. So block spot instances during a specified time frame, 1 to 6 hours without interruption. In rare situation, the instance may be reclaimed. So here other strategy is also spot block. Here we can take that spot instance for specific time frame. So used for batch job data analysis or workload data is lane to failures, not great for critical job. Okay. So EC2 spot instances pricing. So let's talk about how to terminate spot instances. So for terminating spot instances, here basically graph is given. So by seeing this graph we can conclude our request can have open, active, disabled or closed or cancelled and failed states. So we can cancel our request only when it's come from open or active or disabled. So we can only cancel spot instances request that are open, active or disabled. So we make a conclusion. And second one is cancelling a spot request does not terminate instances. So this is the most important point, please remember it. So cancelling a spot request does not terminate instances. We first cancel a spot request, then terminate the associated spot instances. Why? Because when we make a request for spot instances, then it follow a complete pooling process. So when we basically cancel a spot request, then it is already gone into a pulled request, basically queue request. So cancelling spot request does not terminate instance. We must first cancel a spot request and then terminate the associated spot instance. So these are the some most important points regarding the terminating spot instances. So what are the spot fleets? Spot fleets are most interesting spot instances. So spot fleets are set of spot instances plus optional on-demand instances. It means spot fleets are a combination of set of spot instances plus on-demand instances. So spot fleet will try to meet the target capacity with price constraints. Define a possible launch pool, instance type, operating system, availability zone, and we can have multiple launch pools so that the fleets can choose. So spot fleet stops launching instances when reaching capacity or maximum cost. So strategy to allocate spot instances. So there are mainly 3 strategy to allocate spot instances. First one is lowest price, second one is diversified price, third is capacity optimized. So what is lowest price? So from the pool with the lowest price, and for diversified, here we basically choose distributed across all pools, which means we choose for great availability and for longer workload. And last one is for capacity optimized. So pool with optimal capacity for the number of instances here chosen. So spot fleets allow us to automatically request spot instances with the lowest price. Okay, so let's discuss summarize. So let's summarize our EC2 sections. So basically EC2 instance Amazon machine are the Amazon machine images and plus combination of instance CPU, RAM, storage and security groups, and EC2 user data. So what is EC2 instance? EC2 instance is a combination of operating system, CPU, RAM, storage, security groups, EC2 user data. So you can think about it is a virtual server running on any host operating system. So what is security groups? Basically, security groups is a virtual firewall attached to the EC2 instances. What is EC2 user data? A script launched at first start of an instance. What is SSH? SSH stands for basically secure shell. So start a terminal into our EC2 instance. It uses port 22. What is EC2 instance role? Basically, EC2 instance role is a role assigned to EC2 instance by a IAM. What are the purchasing options? So basically, on demand, spot, reserved, standard per convertible, plus schedule, and dedicated host and dedicated instance are the purchasing options for EC2. What's it? So what is EC2 associate? So let's discuss about private versus public IPv4 addresses. So basically, fundamental differences are illustrated here. So public IP means the machine can be identified on the internet. It means we can access that machine or server by using public internet, and must be unique across the whole web. Not two machines can have the any two machine can have the same public IP, and it can be geolocated easily. And next one is private IP. Whereas a private IP means the machine can only be identified in private network only, and the IP must be unique across the private network. But two different private networks or two companies can have the same IP address, and machine connected to World Wide Web using a NAT plus internet gateway, and only a specified range of IP addresses can be used as private IP addresses. So let's talk about the elastic IP. When basically we stop and restart our EC2 instances, then our public IP is changed. So if we need to have a fixed public IP for our instance, then we need an elastic IP. So an elastic IP is a public IPv4 IP we own as long as we don't delete it. So we can attach it to it from our one instance at a time. With an elastic IP address, we can mask the failure of an instance or software by rapidly remapping the addresses to another instance in our account. So we can only have 5 elastic IP address in our account. So we can ask AWS to increase that. So overall, try to avoid using elastic IP. So they often reflect poor architectural decisions, and instead of using a random public IP, we can register a DNS to IP name to it, or we can use load balancer and we don't have to use a public IP address. So basically we can make some hands-on on that. So by default our EC2 machine comes with a private IP for the internal AWS network and a public IP for World Wide Web. So when we are doing SSH into our EC2 machine, we cannot use a private IP because we are not in the same network, and we can only use the public IP. And if our machine is stopped and then started, the public IP can change. So let's move on hands-on. So here I have to close my basically EC2 instances. So here I go from instances, and here I have a basically running instance which have a public IP address and private IP address both. So let's try to access by using SSH. First of all, we try to connect using SSH by using private IPv4 address of instance. So let's SSH. So here we paste our private IP address. Here we can match this both those IP addresses. So here I am using my private IP address to connect from my EC2 instance. Then here we are not able to connect from our instance. Here we can see it in more sophisticated manner. We are not able to connect from our EC2 instance by using the private IP address. So let's try to connect it by using our public IP address. So let's copy the public IPv4 address. So here we copy public IPv4 address, and here we paste it on my terminal. So first of all I have to close my first connection and let paste my public IP address here. So here I pasted my public IP address. You can see here I pasted my public IP address, and I try to connect by using SSH. So you can see here I am able to connect from my EC2 instance. Why? Because the private IP address is not accessible by the internet. So we are not able to even SSH because SSH uses the public internet. So that's why we are not able to connect. So when we use the public IP address of our instance, then we are able to connect from our EC2 instance. So let's exit from our server and minimize our tab and move on next slide. And here if we basically restart our system, then IP address is going to change. So this hands-on is I am basically not doing, because if we restart our system, then also our IP address is public IP can change. So what is placement groups? So basically sometimes we want to control our EC2 instances in placement strategy. So these types of strategy can be defined using placement groups. So when we create a placement group, we specify one of the following strategy for the group. First one is cluster. Clusters instance into cluster instances into allowed a low latency group in single availability zone. And what is spread? Spread instances across underlying hardware, maximum 7 instances per group per availability zone. And what is partition? Spread instances across many different partitions which rely on different set of racks within an availability zone. It scales to hundreds of EC2 instances per group. Like it can be used for Hadoop, Cassandra, Kafka, etc. So let's move further. So first of all we are discuss here placement groups cluster. So in placement group cluster we can use maximum of 7 EC2 instances in a cluster. So here we share the same rack and same availability zone. So placement group cluster are connected with low latency network and high bandwidth, low latency and high bandwidth network like 10 Gbps network. So here all are connected from each other. So what are the pros? So here great network 10 Gbps bandwidth between instances with enhanced networking enabled, which is recommended. So what is the cons? If the rack fails, then all the instances fail at the same time. So let's suppose our rack fail or either our availability zone fails, then all of our EC2 instances are going to fail. So what are the use cases? So basically common use cases include big data job that needs to complete basically fast networking, and application that needs extremely low latency and high network throughput are best suited for clusters. So what are the placement group spread? So basically spread are have in basically these all have different hardware. So this EC2 is on different hardware and this EC2 is in different hardware, and also they are in different availability zone. It means they have different rack, different availability zone. It means if they have different availability zone, then obviously they have different racks. So what are the pros? Pros can span across availability zone. So here there is a multi-availability zone features available. So reduce risk to simultaneous failure. If one of our availability zone fail, then our for instance, let's suppose if we have 6 EC2 instances and we basically deploy our instances in 3 availability zone, and one availability zone contain 2 EC2 instances and on 2 different hardware. If one of the hardware fail, then only our one EC2 instance is going to fail. So cons, what is the cons? So limited to 7 instances per availability zone per placement group. So here we can only put 7 instances in one availability zone. This is the limitation. What is the use cases? So basically use cases is application that needs to maximize high availability and critical application where each instance must be isolated from failure from each other. Okay. So let's move into further. So what is placement groups partition? So here we can make a 7 partition per availability zone, and one availability zone can have 7 partitions, and every partition can be made on different rack on the same availability zone. So up to 100 EC2 instances can in this partition group we can only make 100 EC2 instances. So the instance in a partition do not share rack with the instances in the other partition. So the partition 1 can have same rank, but partition 2 does not have the same rank as partition 1, although they are in same availability zone. So EC2 instances get access to the partition information as metadata, and use cases HDF, HBase, Cassandra, and Kafka. Like all the use cases of placement group, either it is in form of cluster or partition, can be interchanged as per requirement. So let's talk about Elastic Network Interface, ENI. What is Elastic Network Interface? So basically, Elastic Network Interface is a logical component in a VPC that represents a virtual network core. The ENI can have the following attributes. First attribute is primary private IPv4 address, one elastic IPv4 per private IPv4, one public IPv4 address, and one or more security groups, and one MAC address. You can create Elastic Network Interface independently and attach to them on the fly, or move them into one EC2 instances for failover, or bound to a specific availability zone. Like these two basically Elastic Network Interface are attached from that EC2 instance, and this Elastic Network Interface is also attached from two EC2 instances. Okay, so let's move further. What is EC2 Hibernate? So we know we can stop, terminate instances. So stop, the data on the disk EBS is kept intact in the next start. So terminate, any EBS volume root also set up to be destroyed or lost. So on start, the following happens. First start, the operating system boots and the EC2 user data script is run. So following start, the OS boots up. Then our application start cache get warmed up, and that can take time. So to removing the discussed basically drawback, it is recommended to use hibernating. So here in hibernating, where our RAM state is basically preserved, the instance boot much faster, so OS is not stopped or restarted. Under the boot, the RAM state is written to a file in the root EBS volume. The root EBS volume must be encrypted. So for using the hibernating feature, we must encrypt the root EBS volume, and also our volume size is able to contain the OS information. So what are the use cases? Basically, long running process saving the RAM state services that make time to initialize. So for that we are using EC2 hibernate feature. So you can basically if you talk about some hands on this, so we can go on our EC2 instances, and when let's first of all close my first instance, and when I try to launch a new instance, it is basically T2 micro, and here we have a option to set the hibernation turned on or off. So here we can enable the hibernation as an additional stop behavior. So here to enable hibernation, Space is allocated on the root volume to store the instance memory RAM. Make sure that the root volume is large enough to store the RAM contents and accommodate your expected usage, like operating system application. To use hibernation, the root volume must be in encrypted EBS volume. So these are the requirement of basically to apply the hibernation on our system. So basically this is I am lifting on your behalf. You can do that practical from ourselves. So I am not launching this instance, so I want to only show these features can be enabled or disabled during the configuration of instance details. Okay, so let's move to our next slide. So EC2 Hibernate, some important point related to EC2 hibernation. So supported instance families are like C3, C4, C5 and M3, M4, M5, R3, R4 and R5, and T series, ATM series and C series and R series support the hibernation. So instance RAM size must be less than 150 gigabyte. So for using hibernation, instance RAM size must be less than 150 GB, and instance size not supported for bare metal instances. And AMI, Amazon Linux 2, Linux AIMI, Ubuntu and Windows are the only support the hibernating. And root volume must be EBS encrypted non-instance system and large enough to store the RAM content. And instance cannot be hibernated more than 60 days. Okay, so these are the points which must be remembered. Let's move on, new slide. Let's talk about EC2 Nitros. So underlying platform for the next generation of EC2 instances. So EC2 Nitro is a new virtualization technology, basically allow better performance, better networking option, like it is used for it can be used for enhanced networking, high performance computing and for IPv6. So Nitro EC2 instance basically give higher speed than EBS. So Nitro virtualization technology is required for when we require 64,000 EBS IOs, because a non-Nitro EBS volume can give only 32,000 maximum IOs. So it gives better security and instance type. Example that are using basically Nitro system like A1, C5, C5A and many more. And bare metal EC2 instance type that are using Nitro system are A1 metal, C5 metal, C5D metal and many more. So let's move on for the next slide. So let's talk about EC2 virtual CPUs. So multiple threads can run on one CPU because they are using multi-threading concept. So each thread is represented as a virtual CPU. And example M5 2X large has 4 CPU through 2 threads per CPU. So 8 virtual CPU in total. So like M5 2X log have 4 CPU, core 1, core 2, core 3 and core 4, and one core can run 2 threads. So that's why we have total 8 virtual CPU. Let's move further. So what are the optimizing CPU optimization option available in EC2? So EC2 instances basically comes with a combination of RAM and virtual CPU. So in some cases we may want to change the virtual CPU options. So like we can want to change CPU cores and threads per core. So we can basically change per edge configuration we require. It can be only specified during the instance launch time. Okay. So what is the EC2 capacity reservation? So capacity reservation is ensuring about we have a EC2 capacity when needed, manual or planned in date or the reservation. So no need for 1 or 3 year commitment. So capacity access is immediate. You or get billed as soon as it start. So basically here we can specify the availability zone in which we have to reserve the capacity, and the number of instances for which we want to reserve capacity, and the instance attribute including the instance type, tenancy and platform and operating system. We can combine the reserved instances and saving plan to do cost saving. So let's discuss about new section, which is EC2 instance storage section. This is the most important section of AWS because every time we are launching our instance or we are basically launching any database, or either it is managed or not managed, we are using the storage devices. So first off, let's talk about what is an EBS volume. So basically EBS is stand for Elastic Block Store Volume. It is a network drive we can attach from our instance while they run. It allows our instances to persist data even after their termination. They can only be mounted to one instance at a time at the CCP level. So basically they are bound to a specific availability zone. What are the analogy? We can think them as a network USB stick, and free tier have 30 GB of free EBS storage. Of general purpose SSD. General purpose SSD is also known as GP2. So let's move further. Let's talk about the EBS volume. So EBS volume is a network drive, not a physical drive. So always remember, EBS volume is a network drive. So it uses the network to communicate the instances, which means there might be a bit of latency. So it can be detached from an EC2 instance and attached from another one quickly. It can be basically all the EBS volume is logged to an availability zone. An EBS volume in US East 1A cannot be attached from a different availability zone like from US East 1B. To move a volume across, first we need to make a snapshot of that volume. have provisioned capacity size in GB or in IOPS. So we get billed for all the provisioned capacity. So we can increase the capacity of the drive over time as per our requirement. So let's move further. So here are the some examples. So here we have US East 1A. Here we attached a EBS volume from our EC2 instance. So here our two basically volume are connected from EC2 instances, but this EBS volume cannot be connected from US East 1B. And here in US East 1B we have a EC2 instance and connected EBS volume and also a unattached EBS volume. So let's move further. So EBS delete on termination attribute. So we can control the EBS behavior when an EC2 instance terminates. So by default the root EBS volume is deleted attribute enabled. So by default any other attached EBS volume is not deleted, and this attribute is basically disabled. So here in the diagram we can clearly see it. So this can be controlled by the AWS console or AWS command line interface. So use cases preserve root volume when instance is terminated. So we can basically see it on our hands-on. So let's go to our EC2 management console and search for EC2 dashboard, and let's try to create a new EC2. Basically let's create on launch instance. Here we can select T2 micro, configure instance details, and here we go for add storage. So here we can clearly see. So here we add a new volume which is typed with EBS, and so here we can clearly see delete on termination is basically enabled by default, and when we create a new EBS volume then it is not enabled by default. So let's cancel it and we go to our slide. So let's move further on our next slide. So what is EBS snapshot? So to make a backup or snapshot of our EBS volume at a point of time, we use snapshot feature of EBS. So it is not necessary to detach volume to do snapshot, but it is recommended. So we can copy snapshot across availability zone or region. Like if we make a snapshot of that and we store it in S3 bucket and we restore it in different region. Let's move further. Let's talk about AMI. What is AMI? Basically AMI is stand for Amazon Machine Image. So AMI are customization of an EC2 instance. So we add our own software configuration, operating system and monitoring tools and softwares. And for faster boot configuration time, because all our software is pre-packaged, and AMI are built for a specific region and can be copied across region. We can launch EC2 instances from a public AMI like it is AWS provided or any third party provided. So we can also use our own AMI to make and maintain by ourselves, and we can buy any AMI by using AWS Marketplace, which AMI are basically potentially sales by some other users. So what is the AMI process? So here we can first of all start an EC2 instance and customize it according to our need, and then stop the instance for data integrity, and we can build an AMI. This will create a EBS snapshot. So basically launch instance from other AMIs. So here is the process is basically illustrated here. We basically make a snapshot, or we create a AMI of that EC2 instance which has a required configuration. So it is just like taking a snapshot. So these are the generally a snapshot store, and here we make a custom AMI and we launch that AMI in different availability zone. So what is EC2 instance store? Basically EC2 instance store is good, but they have limited performance. If we need a high performance hardware disk, then we sorry for that. Basically EBS volume or network drive with good but limited performance, not EC2 instance store. Sorry for that. Okay, so don't confuse it. So here first line talk about EBS volumes. So EBS volume are network drive with good but limited performance. So if we need a high performance hardware disk, then we use EC2 instance store. These are better, they have better I/O performance, and EC2 instance store lost their storage if they are stopped, and they are good for buffer, cache, scratch data and temporary content. There is a risk of data loss if hardware fails, so backup and replication is our responsibility. So please use EC2 instance store with care. So here we got very high IOs, like if we talk about some local EC2 instance store, then here is the read IOs and write IOs is given for some EC2 instance. So here we can get 2 million random read IOs and 1.6 million of write IOs, which is a very high IOs. IOs is basically stand for input output per second. So you are basically writing 1.6 million of input output write per second. So this is such a very high rate IOs. So let's talk about EBS volume types. So basically EBS volumes comes in 6 types: GP2, GP3, SSD. So basically general purpose SSD volume that balance price and performance for a wide variety of workloads. And second one is IO1, IO2 SSD. They are the highest performance SSD volume for mission critical low latency or high throughput workload. And next one is ST1 SSD, low cost hard disk drive volume designed for frequently accessed throughput intensive workload. And last one is SG1 hard disk drive, lowest cost hard disk drive volume designed for less frequently accessed workload. So EBS volume are basically characterized in size, throughput, IOPS. So when we have any doubt, always consult to AWS documentation. We give so by following AWS documentation, we get a good knowledge about these types. So only GP2, GP3 and IO1 and IO2 can be used as a boot volumes. So here point to be remember is only GP2, GP3 and IO1, IO2 can be used as a boot volume. We cannot use hard disk drive to boot as a boot volume, although we can use magnetic disk to boot as a boot volumes. Let's move further. EBS volume types use cases. General purpose SSD. Basically, this is a cost-effective storage, low latency, having low latency, and system boot volumes, virtual desktop, development and test environment. And here we can get RAM from 1 GB to 16 TB of RAM. So let's talk about GP3. So baseline of GP3 is 3000 IOPS and throughput is 125 megabits per second. And GP3 IOPS can be increased to 60,000 and throughput can be increased up to 1000 TB per second independently. Let's talk about GP2. So small GP2 volumes can burst up to IOPS 3000 and size of the volume and IOPS are linked. So maximum IOPS is 60,000 and 3 IOPS per GB means that 5334 GB we get the maximum IOPS. So basically, what is the use cases of EBS volume types? Basically, when you talk about the provisioned IOPS SSD, so critical business application that required very high performance IOPS performance. So basically, application that need more than 60,000 IOPS can use provisioned IOPS SSD. So I1 and IO2 are basically come into category of provisioned IOPS SSD, and here we can basically use 4 GB of memory to 16 TB of basically volume. So maximum provisioned IOPS is 64,000 for Nitro EC2 instances and 32,000 for other, and can increase provisioned IOPS independently from storage size. So IO2 can have more durability and more IOPS per GB at the same price as IO1. So this is recommended to use IO2 block express. So IO2 block express has sub-milliseconds of latency. So maximum provisioned IOPS can be increased up to basically 256,000 with an IOPS GB ratio of 1000 to 1. Supports EBS multi-attach. It means we can attach it with multiple EC2 instances. Okay, let's move further. So let's talk about the EBS volume type use cases of hard disk drive. So hard disk drive cannot be a boot volume. It gave storage capacity of 120 to 125 MB to 16 terabyte. So throughput optimized hard disk drive ST1 can be used for big data, data warehousing and log processing. And maximum throughput is 500 megabits per second and maximum IO is 500. And cold hard disk drive have like S1 can be used for infrequently accessed data and scenarios where lower cost is important, and maximum throughput is 250 MB and maximum IOPS is 250. So here is a EBS volume type summary is given. You can snapshot it and can be read. Okay, I move further from here. So what is EBS multi-attach? So EBS multi-attach family, EBS multi-attach can be enabled on only IO1 or on IO2 family. So attach the same EBS volume to multiple EC2 instances in the same availability zone. So each instance has full read and write permission to the volume. Here, as I say, here in one availability zone there is a 3 EC2 instance and only one volume. So here IO2 volume is connected, IO2 volume with multi-attach. So here this is the described here. So what is the use cases? Achieve higher application availability in clustered Linux application like Teradata. Applications must manage concurrent write operation and must use a file system that is cluster aware. So we cannot use XFS or ex4 etc. Let's move further. Basically, what are the options? Let's discuss about options related to EBS encryption. So when we create an encrypted EBS volume, we get the following. First of all, data at rest is encrypted inside the volume. All the data in flight moving between the instances and the volume is encrypted, and all snapshots are encrypted. So all volumes created from the snapshot, so encryption and decryption are handled transparently. We do not have to do anything. So encryption has a minimal impact on latency. EBS encryption leverage keys from KMS and AES 256. Copying an unencrypted snapshot allows encryption snapshot of encrypted volume are encrypted. So here snapshot of encrypted volume are also encrypted. So how we can encrypt an unencrypted EBS volume? Here are the steps. First of all, create an EBS snapshot of that volume and encrypt the EBS snapshot by using copy. So create a new EBS volume from the snapshot. The volume will also be encrypted. Now we can attach that encrypted volume to our original instance. EBS RAID options. So EBS is already a redundant storage replicated within an availability zone. But what if you want to increase IOPS to say 1 lakh IOPS? So what if you want to mirror your EBS volume? We would mount volume in parallel in RAID setting. So what is RAID? RAID is stand for basically redundant array of basically inexpensive disk or independent disk. So I somewhere is mentioned as independent disk and somewhere inexpensive disk. But here I think RAD is stand for redundant array of independent disk. So RAD is possible as long as our operating system support it. Some RAD options are like RAD 0, RAD 1. RAD 0 uses data stripping, RAD 1 uses data replication, and so RAD 5 and RAD 6 both are not recommended for AWS. For more information, we can explore the AWS documentation. So we will explore RAD 0 and RAD 1 here. So what is RAD 0? RAD 0 basically increase performance, combining two or more volumes and getting the total disk space in I/O. But one disk fails, all data is failed. So use cases would be an application that needs a lot of I/Os and does not need fault tolerance. A database that has a replication already built in. So using this we can have a very big disk with a lot of I/Os. For example, two 500 gigabytes of Amazon EBS IO1 volume with 4000 provisioned I/Os, which will create a 1000 gigabits of RAD 0 array with an available bandwidth of 8000 I/Os and 1000 megabits per second of throughput. So here concept of RAD 0 is illustrated by figure. Though these both volume EBS volume is work as a one logical volume. Let's talk about the RAD 1. So basically RAD 1 increases the fault tolerance. So RAD 1 uses the mirroring of a volume to another. So if one disk fails, our logical volume is still working. We have to send the data to the EBS volume at the same time. So use cases may include applications that need increased volume fault tolerance, applications where need to service disk. For example, if we have two 500 gigabits Amazon EBS IO1 volumes with 4000 provisioned IOs, which will create a 500 gigabytes RAD 1 array with an available bandwidth of 4000 IOs and 500 megabytes of throughput. Okay. So let's talk about the important concept of AWS, which is elastic file system. So managed NFS network file system that can be mounted on many EC2. So EFS work with EC2 instances in multi-availability zone. So highly available, scalable, expensive, 3 times more expensive than GP2, and it is also a pay per use. So here we can connect the basically EC2 instances which belongs from different region or from different availability zones. So here the concept is illustrated here. Let's move further. So use cases may include like content management, web serving, data sharing, WordPress, and it uses NFS version 4.1 protocol. It uses security group to control access to the elastic file system. So EFS is compatible with Linux-based AMIs, it is not for Windows AMI. So encryption at rest by using key management services KMS. So POSIX file system that has a standard file API. So basically file system scales automatically, pay per use, no capacity planning. Let's move further. So What are the performance and storage class available in Elastic File System? So basically, Elastic File System scales 1000 of concurrent NFS clients. So basically, it can manage 1000 of concurrent NFS client and 10 GB per second of throughput, which is a very high amount of throughput. It can grow to petabyte of network scale file system automatically. Performance mode set at EFS creation time. General purpose is set as default. Latency sensitive use cases, web server, CMS, etc. Maximum high input output, high latency throughput, highly parallel big data media processing. And in throughput mode, basically we can set bursting, like 1 terabyte is equal to 550 megabytes per second plus burst up to 100 megabytes per second. So if throughput is provisioned, then we can set our throughput regardless of our storage size. Example, 1 gigabyte for 1 terabyte of storage. So what is about storage tiers? Lifecycle management features: move file after endage, standard for frequently accessed file, and EFSIA, infrequent access, for minimizing the cost or cost to retrieve files, lower price to store. So here we can set a lifecycle basically for our data, like which data is frequently used, we can put it into the standard EFS, and which data is basically infrequently used, we can put into the EFS input IA. Let's talk about storage tiers. So basically it is a life cycle management features. We can move by high after endage, as I discussed in previous. So let's move further. So EBS versus EFS. First of all, EBS, we discuss about EBS volumes. It can be attached to only one instance at a time. They are locked at one availability zone level. So basically GP2 IO increases if the disk size increases. IO1 can increase input output independently. To migrate an EBS volume across availability zone, here we have to follow some steps. First of all, take a snapshot of EBS volume, then restore the snapshot to another availability zone. So EBS backup uses input output and we should not run them so while our application is handling a lot of traffic. Root EBS volume of instances get terminated by default. If the EC2 instance get terminated, we can disable it. Here is a example is given, like if you want to make a snapshot of that EC2 into different availability zone, then we first of all we make a snapshot of EBS volume and we store it in S3 bucket, and then we can restore from there to a different availability zone. So EBS versus EFS. Point 2, we mount hundreds of instances across availability zone, and EFS share website files like WordPress and any other CMS. Only for EFS is only for Linux instance. EFS has a higher price point than EBS, approximately 3 times more price. We can leverage EFS, infrequent access file cost saving. Remember the difference between elastic file system, elastic block storage, and instance store. So let's move on AWS fundamentals part 2. So let's discuss about this concept. So basically in this part we are going to discuss about load balancing, auto scaling groups, and EBS volumes. So let's move further. So here we want to discuss about what is scalability and high availability. So scalability means that an application or system can handle greater loads by adapting. And there are two kinds of scalability. First one is vertical scalability and second one is horizontal scalability. Point noted here, horizontal scalability is known as elasticity. So here in our exam question may be asked what do you understand by vertical scalability, and or what do you understand by scalability and elasticity, how these both concepts are different. Then here is a straightforward answer. Vertical scalability is termed as scalability, whereas horizontal scalability is termed as elasticity. So scalability is very closely linked with high availability, but scalability is different from high availability. So let's deep dive into the discussion. So let's call center example. So what is vertical scalability? Vertically scalability means increasing the size of the instances. Here for example, if our application runs on T2 micro and we have need to vertically scale it, then running it on T2 large is termed as vertical scalability. So in first scenario we are using T2 micro, and when we vertically scan it means we are going to use the T2 large. So vertical scalability is very common for a non-distributed system such as databases. So relational database system like and elastic cache are services that can scale vertically. So there is usually a limit to how much you can vertically scale. These limits are hardware limits. Like here is a junior operator in our call center, and junior operator is not able to handle all the tasks or all the workload which we have assigned to that junior operator. Then we assign same workload and task to senior operator because junior operator is not able to handle. But here as junior we assign all the tasks to only one operator, which is a senior operator, which is more capable to do that task as compared to junior operator. So let's move further. So what is horizontal scalability? So horizontal scalability means increasing the number of instances or system of our application. So horizontal scaling implies undistributed system, and this is very common for web application and modern application. It is easy to horizontally scale thanks to offering such as Amazon EC2. Like if one operator is not able to handle the assigned tasks, then we here gave the distribute or allocate same task within multiple operators. Like here we increases the number of operators. Here we did not use the concept of junior operator or senior operator. All operator has same capability to handle all the tasks. So let's move on further. So what is high availability? So high availability usually goes hand in hands with horizontal scaling. So high availability means running our application system in at least 2 data centers or 2 availability zones. The goal of high availability is to survive a data center loss. The high availability can be passive for RDS multi-availability zone, and the high availability can be active for horizontal scaling. Like we have a first building in New York and second building in San Francisco. So here we can use the concept of high availability. If our first building in New York is attacked by the terrorist or it is defected by some basically physical disaster like flood, then in this case we can use our second building of San Francisco for operating our day-to-day work and task. So what is the meaning of high availability and scalability for EC2? So basically vertical scaling increases the instance size. So from with T2 Nano 0.5 gigabits RAM V1 CPU to Ultra 12 TB1 Metal 12.3 terabytes of RAM 448 virtual CPU. So here we move from T2 Micro to U12 TB1 Metal, which is a perfect example of vertical scaling. And what is horizontal scaling? Increasing the number of instances. So auto scaling group, load balancer are used for horizontal scaling. And here a point must be noticed: horizontal scaling is known as scale out, and decreasing the number of instances is known as scale in. Whereas in vertical scaling, if we scale from T2 Nano to U12 TB1 Metal, then it is known as scale up. Whereas when we reducing the size of instance, then it is known as scale down. So these 2 points must be remembered. Okay. So high availability. Run instances for the same application across multiple availability zones. So auto scaling group multi-availability zone. We can use auto scaling group multi-AG and load balancer multi-AG for high availability. Let's move further. So let's discuss the concept of load balancing. What is load balancing basically? So load balancers are servers that forward traffic to multiple servers, like multiple downstream EC2 instances. Like we have some users, they are basically connected with elastic load balancer. Then our load balancer distributed the basically all our traffic into these EC2 instances. So here load balancer policy may be decided which policy we are using at load balancer. It decides how many traffic goes to these instances. So let's move further. So why use a load balancer? So basically, what is the use of load balancer? So main uses of load balancer is discussed here. First one is spread load across multiple downstream instances, and second one is expose a single point of access DNS to our application. Basically, DNS is stand for domain name server or domain name system. Seamless handle failures of downstream instances and do regular health checks of our instances, provide SSL termination of our website, and enforce stickiness with cookies and high availability across zones, and separate public traffic from private traffic. So let's move further. Why use an elastic load balancer? So as we discussed some point in previous slide, so let's discuss some more points. So an elastic load balancer is basically a managed load balancer where AWS guarantees that it will be working. AWS take care of upgrades, maintenance, and high availability of load balancer. AWS provides only a few configuration nodes. It costs less to set up your own load balancer, but it will be a lot more effort on your end. So it is integrated with many AWS offering or services, like from it is integrated with EC2 auto scaling route, Amazon Elastic Container Services, and it's also integrated with AWS Certificate Manager ACM, which is also known as ACM, and also it is well integrated with CloudWatch and Route 53, AWS Web Application Firewall, and AWS Global Accelerator. So let's move further. So what is the load balancer health checks? So basically, health checks are crucial for load balancers. They enable the load balancer to know if instances with forward traffic to are available to replay to request. So the health check is done on a part and a route, basically a port and on a route. So if the response is not 200 OK, then the instance is unhealthy. So here a diagram is given to illustrate the concept. Let's move further. So types of load balancer on AWS. So AWS has 4 kinds of managed load balancer. First one is classic load balancer, which is a old generation load balancer, which has a capability of HTTP, HTTPS, TCP, and SSL. It supports this protocol, and it also supports the secure STCP. Basically, STCP uses SSL. So application load balancer version 2, this is a new generation of load balancer, which is basically launched in 2016. It supports HTTP, HTTPS, and WebSocket protocols. And third one is network load balancer. It is also a version 2 and new generation, and it's introduced in 2017. So it supports basically TCP, TLS, and secure TCP, UDP protocols. So it is basically a application layer. It's work on application layers of OSI. Whereas application load balancer, So network load balancer are work at basically a transport layer, and application load balancer are work at application layer. So what is gateway load balancers? So basically gateway layer balancer are introduced in 2020. So it's operate at third layer, and it's which is a network layer in OSI model basically, and it support the IP protocol basically, which is internet protocol. Overall, it is recommended to use the newer generation load balancer as they provide more features, and some load balancers can be set up as internal private or external private elastic load balancers. Let's move on next slide. So what is a load balancer security group? So here users can make any request from load balancer, and HTTP restricted to load balancers, and this request is basically transferred to EC2, and EC2 give response to load balancer, and load balancer then transfers those response to user. So here a security group table is given here. So basically security groups table contain the basically 5 parts, which is type, protocol, port range, source and description. Basically type illustrate the protocol type, and protocol is always set to TCP, and the port range is the port on which that basically process is going to communicate, and source is the IP address from where this request may be originated, and here description is also given. So here this is the load balancer security group table basically, and this is the application security group allow traffic only from load balancer. So this is the basically EC2 security group which only allow the HTTP traffic only from load balancer, because here source is set to only the load balancer. It means it only accept the traffic from load balancer. So no any other traffic is allowed here. So any users cannot directly communicate with this EC2 instance. If any users want to communicate from that EC2 instance, then you must have to connect from load balancer first, and then load balancer transfer that request to the EC2, and on this basis EC2 give the response to load balancer, and load balancer transfer that response to users. So let's move further. Let's discuss about classic load balancers. So as we discussed in previous slide, it supports the TCP layer 4, basically HTTP and HTTPS of layer 7, and its hull checks are TCP or HTTP based, and fixed host name. They have also a fixed host name, like if SSH.region.elb, Amazon, AWS.com. So here basically client gave a request to listen classic load balancer listener, and then listener internally transferred that request to EC2. So let's move further, and here we discuss about the application load balancer, which is a version 2 based load balancer. So basically it's work on application layer, which is a 7th layer in OSI model, and it uses the concept of HTTP. So load balancing to multiple HTTP application across machine, and load balancing to multiple application on the same machine, which is used in containers basically. So it supports HTTP version 2 and HTTP and WebSocket protocols. It supports redirects from HTTP to HTTPS and many more. Redirects are also supported by the application load balancer. So here only one condition is it belongs from all protocol must be belongs from layer 7. So let's talk about application load balancer target groups. So basically EC2 instance can be managed by an auto scaling group which follow the hypertext transfer protocol, and elastic container services tasks can be managed by basically itself which follow the hypertext transfer protocol, and also lambda functions hypertext transfer protocol request can be translated into JSON's event. Okay, so for IP addresses we must use the private IP addresses. So application load balancer can route the basic overall traffic to multiple target groups, and health checks are at the target group level. So what is about application load balancer version 2 query string and parameter routing? So here users request is come from World Wide Web, and here we are using external application load balancer. So here first platform is equal to mobile in our query parameter, and second one contain the platform desktop. So on the basis of these parameters, query parameters or query strings, we can basically send our traffic to different target group. Like if our parameters contain platform is equal to mobile, then we have to send traffic to target group 1, and if platform is equal to desktop, then we send this traffic to target group. So these are the on-premises basically private IP routing. So here how we will know we have to send these parameter to these EC2 instances, and these EC2 instances are able to response, are able to give response in proper manner, and they have proper load capacity. So all this information we can gather from analytics, like if you are using Google Analytics or some another third-party analytics. So we can use analytics to find information how much traffic we have to send to target group 1, and how much traffic we have to send target group 2, and how many active users, how many users are coming on our website by using platform is equal to mobile, or platform as a mobile, and how many users, how much traffic come by using desktop. So on this basis we can basically divide our overall traffic into different target groups. Okay, so let's move to new slide. So what are the basic important points related to application load balancer? So application load balancer has a fixed host name, which host name is anything, and region.elb.amazon.aws.com, and the application server don't see the IP of the client directly. the true IP of the client is inserted in the header X forwarded for, and we can also get port X forwarded for and proto X forwarded proto. So here if client request by using some IP address, then IP address is not known directly to client, because here a mediator, here our application load balancer is work as a mediator. He said you have to only, client have to only contact with me, and I client have to give request to only me, and I forward that request to basically EC2 instance, and the EC2 instance is responsible to only give response to the application load balancer. Then application load balancer is going to forward that response to the client. So here no direct communication maybe happen with EC2 instance. So let's move on to new slide. So let's talk about network load balancers version 2. So basically network load balancers are layer 4. Basically these are all the transport layer protocols. So this network load balancer support transport layer protocols like TCP, UDP and many more, which protocol basically supported by the network layer. Not network layer, this is transport layer. So they forward TCP and UDP traffic to our instances, and they handle millions of requests per second. So network load balancer can handle millions of requests per second, and they have very low latency. And network load balancer has one static IP per availability zone and supports assigning elastic IP. And here this feature is used very helpful for whitelisting some specific IP addresses. And the network load balancer are used for extreme performance, which support basically transmission control protocol and user datagram protocol traffic. And network load balancer is not come into AWS free tier, so you are not able to perform free hands-on this network load balancer. Let's try to understand the concept of network load balancer. Here basically user gave request to our network load balancer by using www World Wide Web, and her request contained TCP transmission control protocol plus some rules. So our external load balancer, network load balancer basically accept that request based on her protocol, and then forward it to her target group. And here also network load balancer basically here forward traffic based on her protocols. So here we can see there is two different types of protocol is supported by the network load balancer. We all know network load balancer support only TCP, UDP. So how this can be communicated with HTTP, hypertext transfer protocol. So basically main funda is here. Any network any load balancer can support any protocol, but for which the but network load balancer are only optimized for TCP and UDP, and the main task of here is to only manage the transmission control protocol and user datagram protocol. Here we can see all the responses to users is only forwarded by the TCP or rules. Here UDP can be also used. So here in this example we only use TCP plus rules, and also this network load balancer can make connection by using any of the protocol. So here there is no requirement or no boundary protocol is decided to communicate network between the communication for network load balancer and our target group. Okay, so let's move on, new slide. What is sticky sessions or session affinity? So basically it is possible to implement stickiness so that the same client is always redirected to the same instance behind a load balancer. This works for classic load balancer and also for application load balancer. The cookie is used for stickiness as an expiration that you control. Use case makes sure the user does not load his session data. So enabling stickiness may bring imbalance to the load over the backend EC2 instance. So basically we all know hypertext transfer protocol is a stateless protocol. It means it does not know if client sends some request to our application load balancer. Then as we know, here we are using HTTP protocol or HTTPS protocol. So both are stateless protocol. They don't know from which EC2 instance we are going to connect, and every request here, every HTTP request is basically independent to each request. Means only HTTP are not able to decide from which EC2 instance I have to communicate. So for this purpose we use sticky sessions by which our HTTP request can decide from which EC2 instance I have to connect, because sometimes if we are performing any task, if we are logging into our application and one HTTP request goes to that EC2, this EC2 instance, and another request goes to different EC2 instance, then how we are able to basically perform our all activity? Because if one request is given to this EC2 instance and second one is given to this EC2 instance, then we are not able to basically perform any task, because every time we make a new request we have to log in. Every time we make a new request we have to log in into our account. So say sticky sessions solve this problem. So basically for making a session we use concept of cookies. So cookies is basically comes to our HTTP request, and when cookies goes to our application load balancer, then application load balancer is able to depict to which EC2 instance I have to forward that request. So here we can say here client 1 send 2 HTTP requests and both HTTP requests are goes to EC2 instance, first EC2 instance. So these all are possible with the help of sticky session because HTTP hypertext transfer protocol is itself stateless. So make it stateful. To make hypertext transfer protocol stateful, we have to add cookies in our request header. So by which our basically application load balancer able to depict to for which EC2 instance we have to forward that request. So here point may be noted that enabling stickiness may bring imbalance to the load over the backend EC2 instances. Okay, so let's move into next slide. Let's talk about what is cross zone load balancing. So here is the figure of by using cross zone load balancing and without cross zone load balancing. So if we are using cross zone load balancing, then if there are basically two load balancer, then each if load balancer 1 or target group 1 contain basically it may be connected with same load balancer with different target groups. So if target group 1 contain only 2 EC2 instances and our target group second contain 8 instances, then each if we enable cross zone load balancing, then each EC2 instance have same load. It means here each EC2 instance get same traffic. Okay, but if we not enable cross zone load balancing, then here what happens? This whole traffic is divided into two parts, and after that this group basically have only 2 EC2 instances, but all traffic is next divided into only 25 to 25. It means all traffic is divided into only for that, and here all EC2 instances has only 6.25% of traffic per instance. So this is the main difference between these two things. So as per our requirement, we can enable cross zone load balancing. So here each load balancer instance distributes evenly across all registers instance in all availability zone. Okay, or without cross zone load balancing, requests are distributed in the instance of the node of the elastic load balancer. So some facts about cross zone load balancing here is application load balancer. First one is application load balancer is always on and it cannot be disabled, and no charges for inter availability zone data. And for network load balancer, it is disabled by default, and we have to pay charges for inter availability zone data if enabled. And for classic load balancer, we have option through console to enable. If we are using console, then it is enabled by default. If we are using CLI, command line interface, application programming interface, then it is disabled by default. So no charges for interoperability zone data if enabled. So SSL, basically SSL is stand for Secure Circuit Layer and TLS is Transport Layer Security. So let's understand some basic facts about SSL and TLS. So an SSL certificate allows traffic between our clients and our load balancer to be encrypted in transit. It means it allows us to in-flight encryption. SSL refers to Secure Socket Layer used to encrypt connection. And TLS refers to Transport Layer Security, which is a newer version of SSL. So nowadays TLS certificates are mainly used, but people still refer as SSL. Public SSL certificates are issued by the certificate authorities, which is also known as CS. So basically some certificate authorities are like Komodo, Symantec, GoDaddy, GlobalSign, DigiCert, Let's Encrypt, etc. So basically SSL certificate have an expiration date. So we have to renew it. So let's understand how SSL certificates work with load balancer. So here first user request from load balancer. Then this request is also encrypted by using HTTPS, basically SSL certificate. To make HTTP into HTTPS, we use SSL certificates. Then load balancer transfer that request only by using HTTP. So here, so the load balancer uses an X.509 certificate and SSL TLS server certificate. You can manage your certificate using ACM, which is AWS Certificate Manager. We can create, upload our own certificate alternatively. So there is no limitation to use a certificate from certificate authority. We can also use our certificate. So what is the hypertext transfer protocol security, listeners? So we have to must specify a default certificate. We can add an optional list of certification to support multiple domains. Client can use server name indication to specify the host name they reach. Ability to specify a security policy. So let's talk about SSL server name indication. Server name indication is also known as SN9. So basically server name indication solves the problem of loading multiple secure certificate layer certificate onto one web server to serve multiple websites. So here we take an example. Let's suppose client requested a basically URL from ALB. Then here ALB's responsibility is that she have to basically load the exact or correct load basically load balancer have responsibility to load correct SSL certificate from their list to bind from that URL. So this is the basically application load balancer's responsibility, because they may contain more than one SSL certificate and they can be also connected with more than one domains. So it is the basically application load balancer responsibility to bind the SSL certificate with right domain. So how application load balancer perform this? Application load balancer perform this by using the help of server name indications. So basically server name indication is a newer protocol and it requires the client to indicate the host name of the target server in the initial SSL handshake. The server will then find the correct certificate or return the default one. And it only works for with application load balancer and network load balancers and CloudFront. It does not work with classic load balancer. So let's talk about the elastic load balancer SSL certificates. So first one is classic load balancer, is called version 1 and support only SSL certificate and must be use multiple classic load balancer for multiple host name with multiple SSL certificate. So when we are using classic load balancer, we have to use multiple classic load balancer for multiple host name with multiple SSL certificate. But if you are using version 2 application load balancer, then it supports multiple listeners with multiple SSL certificate. It uses the concept of server name indication to make it work. And here network load balancer version 2 also support multiple listeners with multiple SSL certificate, and it also uses the concept of server name indication to make it work. So here is a concept of connection draining. So what is connection draining? So basically there is a two name used for connection draining. If we are using classic load balancer, then it is called connection draining. But if we are using version 2 application load balancer and network load balancer, then it's called deregistration delay. So we have to remember these both names. It may be connection draining or it can be known as deregistration delay. So let's talk about what is this. So basically time to complete in-flight request while the instance is deregistering or unhealthy. So here is a figure to depict the connection draining. So let's users, we have many users, they all are connected with elastic load balancer, and here first EC2 instance is draining. It means it is basically deregistering itself. So what will we have? What is going to happen? Is it immediately basically disconnected? No, it's must be wait for existing connection to complete before deregistering. So here we have to stop sending new requests to EC2. So basically it is the elastic load balancer responsibility to stop sending new requests to the EC2 instance, which is deregistering. And between 1 to 3600 seconds default 300 seconds, it means 5 minutes each set. So it can be disabled set value to 0. So set to low value if your request are short, and if we have longer request, then we have to set large value. So if what happen with when we set it to the value to 0, then when we set value to 0, then it is forcefully basically discarded all the request which is in request pool, or which is basically transferred by the elastic load balancer. Okay, let's talk about what is an auto scaling group. So in real life, the load on our website and application can change. In the cloud, we can create and write a server very quickly. So the goal of an auto scaling group is to scale out, add EC2 instances to match an increased load, or scale in, remove EC2 instances to match a decreased load. Ensure we have a minimum and a maximum number of machines running. So automatically register new instances to a load balancer. So basically these are the responsibility of auto scaling group. So auto scaling group in AWS. So we have some minimum size of EC2 instances, like we want 3 EC2 instances must be running all time, and if needed, then scale out with more 3 instances and many more. So this may be defined in our auto scaling group policy. So when we use auto scaling group in AWS with load balancer, then load balancer distributed the as per our specified. If you are using cross load balancing enabled, then he distributed the same traffic to both to all of these EC2 instances. If auto scaling group increases that load, basically increases the number of instances, then whole traffic is going to be divided in all the EC2 instances. If basically cross is checked. So this is the basic funda of auto scaling group. Let's move further. So basically auto scaling group have the following attributes: a launch configuration, an AMI instance type, EC2 user data, AWS volume, security groups, SSH key pairs, mean size, max size, initial capacity, plus network and subnet information, load balancer information, and scaling policy. Let's move further. So what is auto scaling allow? So basically it is possible to scale an auto scaling group based on cloud watch allowance. So an allowance monitor a metric such as average CPU. If average CPU is greater than that limit, then we can launch some new EC2 instances. So basically metrics are computed of the overall auto scaling group instances. Based on the alarm, we can create scale out policy, increase the number of instances, or we can create scale in policy, basically decrease the number of instances. So auto scaling new rules. It is now possible to define better auto scaling rules that are directly managed by EC2. So first we can define on the basis of target average CPU usage and by number of requests on the elastic load balancer for instance, average network in, average network out. So basically these rules are easier to set up and can make more sense. So basically we can see it on our hands-on lab. So let's talk about auto scaling custom metrics. So we can auto scale based on our custom metrics. Example, number of connected users. So send custom metrics from application on EC2 to CloudWatch by using put metrics API. API stands for application programming interface. So we can create a CloudWatch alarm to react to low or high values. Use the CloudWatch alarm as the scaling policy for auto scaling group. So what is auto scaling group? Breakdown. So basically scaling policy can be on CPU, network and can even on custom matrices or based on a schedule if you know our visitors pattern. So auto scaling group use launch configuration or launch templates. To update an auto scaling group, we must provide a new launch configuration or launch template. IAM roles attached to an auto scaling group will get assigned to EC2 instances. So basically auto scaling group are free. We have to pay for only underlying resources which are being launched by auto scaling group. So having instance order and auto scaling group means that if they get terminated for whatever reason, the auto scaling group will automatically create new ones as a replacement extra safety. Auto scaling group can terminate instances marked as unhealthy by a load balancer and hence replace them. So what are the basic auto scaling group policies? So basically these are dynamic scaling policy. First one is target tracking scaling. So most simple and easy way to set up. And example, I want to average CPU to stay at around 40%. If when EC2 average CPU utilization increases more than 40%, then we have to basically scale out. And simple or step scaling. When a CloudWatch alarm is triggered, example CPU is greater than 70%, then add 2 units. When a CloudWatch alarm is triggered, example CPU is less than 30%, then we remove 1. And scheduled actions. So basically anticipate scaling based on known usage pattern. Here, like if you take an example, then increase the minimum capacity to 10 at 10 to 5 p.m. on Fridays. So auto scaling group, when we know the previous patterns of basically our users, then by analyzing historical load we can use predictive scaling. So continuously forecast load and schedule scaling ahead. It uses the machine learning concept. So basically some good matrices to scale on. First one is CPU utilization. The average CPU utilization across our instances. Request counter per target to make sure the number of requests per EC2 instance is stable. Our average network in or out if we are in application or network bound. Any custom metrics that we push using CloudWatch. So here is the figure to depict that. So let's talk about cooldowns. What is cooldown? So after a scaling activity happens, we are in the cooldown period and it is default set to 300 seconds. During the cooldown period, the auto scaling group will not launch or terminate any additional instances to allow for matrices to stabilize. So advise you use AMI to reduce configuration time in order to be serving request faster and reduce the cooldown period. So to reduce these cooldown periods, we can use AMIs to configure if we talk about to reduce cooldown period, then we can use AMIs, which are basically pre-configured AMIs. So this is the figure basically which depicted the use of cooldown. If default cooldown in effect, if a scaling action occurs and default cooldown is in effect, then we ignore action, otherwise launch or terminate instances based on scaling actions. Okay, let's move further. So what is use of auto scaling group for solution architect perspective? So auto scaling group with default termination policy. Find the availability zone which has the most number of instances. If there are multiple instances in the availability zone to choose from, delete the one with oldest launch configuration. And auto scaling group 1 basically balances the number of instances across all availability zone by default. So let's suppose if we have two availability zone A, availability zone B, and both are connected with auto scaling group, and availability zone A has 4 EC2 instances and availability zone B has only 3 EC2 instances, then auto scaling group by default it is configured to balance the number of EC2 instances also. So here from availability zone it's basically terminated the oldest the EC2 instance which has oldest launch configuration. So here from version 1 only one instance is going to terminate it. So basically what are the auto scaling group lifecycle hooks as perspective of solution architect? By default, as soon as an instance is launched in an auto scaling group, it is in service. So you have to ability to perform extra steps before the instance goes in service. So we have the ability to perform some actions before the instance is terminated. So let's try to understand this algorithm. If auto scaling group perform a action to scale out, then it goes into pending state. As we launch any instance, then first of all it is go into pending state. So what will happen? So when it is in pending state, then here we can basically configure a hook pending, like it is in pending wait and pending proceed. So and after these two steps, then it is go into in service. It may be go directly into in service, but we can configure some lifecycle hooks. And when it is basically scaling or terminating some instances, then it can also go into some lifecycle hooks. Like before terminating, if we want to perform some action, then proceed to terminating, and then after it is terminated. So basically these lifecycle hooks give we a feature to do some tasks before it is our basically instances are going into service. Like if we basically copy some batch basically is script in user data field, then we are using a lifecycle hook. Like if those action performed, then only our EC2 instance is going into in service. Okay, so let's move further. So let's try to understand the difference between launch template versus launch configuration. So basically both are the identifier of the Amazon machine image, the instance type, a key pair, security group, and the other parameters that we use to launch EC2 instances, like tags, EC2 user data. And the launch configuration in legacy mode must be recreated every time. And the launch template is a newer, so we can have multiple versions of launch template, and we can create parameter subsets and provision it using both on-demand and spot instances. Can use T2 unlimited burst feature and recommended by AWS for going forward because it is a newer version. So launch template is a, we can say launch template is a newer version of launch configuration. So let's talk about some databases like RDS, Aurora, and Elasticsearch. So basically RDS is a relational database system. Okay, so let's talk about it. So before talking about the RDS, so here I forget about the hands-on lab. So first move on to our hands-on lab of this session, which is basically auto scaling group and load balance, elastic load balancer hands-on. So let's go to on our console. So here I have to log in. So basically I pause my video. So here my console page is opened and I have two EC2 instances running in two different availability zones. So make sure for using any elastic load balancer we have instances running in more than one availability zones. So like I have two availability zones, AP South 1A and AP South 1B. So let's create a load balancer. So basically in free tier we can only create application load balancer. So here we click on create load balancer. So here we have the four options. First one is application load balancer, which comes with free tier, and second one is network load balancer, and third one is gateway load balancer, and fourth one is classic load balancer, which is terms into previous generation. And here a notification is also come. AWS will be retiring the EC2 classic network on August 15, 2022. It's announced that this classic load balancer is going to deleted from AWS. So here we use application load balancer. So application load balancer basically work with hypertext transfer protocol and hypertext transfer protocol security. And here when we have to choose application load balancer. So choose an application load balancer when we need a flexible feature set for our web application with HTTP and HTTPS traffic. So operating at the request level, application load balancer provides advanced routing and visibility features targeted at application architecture, including microservices and containers. So let's create an application load balancer. So here you have to give some name to your application load balancer. So here I type demo application load balancer, and of course this is a internet facing load balancer. You can also create some internal load balancers. So here in IP addresses I am using only IPv4. If you are using IPv6, then you can check on dual stack. So network mapping, here a default VPC is already selected. If you want to change this, then you can change, but here I set it default. So mapping, so basically select at least two availability zones. That's why I first time when I come to my EC2 instance console, I say that minimum two availability zone is required here. So let's take AP South 1A and AP South 1B. Because I have two instances running, one instance is running in AP South 1A and second instance is running in AP South 1B. And here is default security group which is associated, but we have to change and modify security group because we are going to communicate with internet. So let's set it is default. We change it later. So here we have to select a target group. So we can click on create target group to create new target group. So here my target type is instance based, and my target group name is demo target group, and set the protocol version at HTTP1, and if you like to use HTTP2 then you can use, but here I use HTTP1 and click on next. And here we have two instances in two different availability zones, so I include it as a pending below. So here they come and I click on create target group. So here our target group is successfully created. So basically here I have 3 target group. So first of all I delete my 2 target group which are basically old target groups. So I can simply click on delete. Yes, delete. So I deleted my previous 2 target group. So let's move into load balancer. So here we refresh it, and here we can here we did not get any result. So why? So let's create one more time. Click on instances and give a target group name. And VPC is auto selected, and click on next. And here we have all EC2 instances list, and we check it on and include as a pending, and click on create target group. And here our target group is created, but I have already one created target group, but it is not loading in my basically target group section. So basically I have to wait. So here my target group is come. So I select my demo target group, and we click on create load balancer. So here my load balancer is successfully created. So here I click on view demo load balancer. So it is now in provisioning state. It can take up to 5 to 10 minutes. So when it is provisioning, if we copy its DNS name, and basically we go into incognito mode and paste this DNS, then we are not going to get any response, because it gave a error, this site cannot be reached, because here our application load balancer is not active. So let's back, and I stop my video. Now our application load balancer is active. So let's copy DNS name and paste it on incognito window, and here. So here we are seeing this is basically searching for that this is trying to connect from our demo application load balancer, but it is not able to connect. So basically we are here going to face a timeout error, because here we did not get either immediate any error response. So here we get a timeout error. So how this timeout, why this timeout error is occurred? So let's move on basically our application load balancers. So what we have to do, we have to edit security groups, and let's use a security group where HTTP and HTTPS both are allowed as a inbound. So we click on save, and then after changing it, we go into incognito window, and here we paste demo ALB. So here we get a response from our server. This response which comes from this IP address. Basically it's come from 172.31.15 and 152. So when we refresh this, basically when we resubmit a request, then we are going to get different IP address, because this time this request is transferred to a different EC2 instance. So let's press Ctrl R. So here we can clearly say now we get a different IP address, which is it means our request is transferred to a different EC2 instance, although we are connected with our only one DNS. So here what will happen? Let's try to understand. So basically we have two EC2 instances in two different availability zones. And this is the basically IP address. Basically when we are getting this IP address, then we can understand this response is come from this instance. So basically let's copy here. So here we can see now this time response is comes with 172-31-15-152. So when we refresh it, then we get the IP address of first instance. So it means this time request is transferred to this instance. It means every time we make a request is going to transfer to different instances. So it evenly distributed our overall traffic to our connected instances. So this is the basic idea of basically application load balancers. So here we can see my IP address is changing every time we submit a new request. So let's continue. Let's dispose it first of all. So we go here and we stop our basically we delete. First of all we delete our elastic load balancer. So here click on actions and click on delete. Yes, delete. And we have also created a placement group, so we have to delete that target group basically. Search here target groups, and here we have to delete this target group because I did not going to use this target group. So click on action and click on delete. Yes, delete. So I deleted my target group. So let's terminate our EC2 instances. So click on here and instance state and terminate instances. So I terminated my one instance, although my one instance is running for next practical purposes. So next move on to next slide. So here we are trying to understand about some databases. So here let's talk about the AWS RDS. So basically RDS is stand for relational database service or relational database system. So let's try to understand what is the basic features of RDS. Okay, so it is a managed database service for database usage such as SQL as a query language. It allows us to create databases in the cloud that are managed by AWS. So types of RDS are supported in AWS is PostgreSQL, MySQL, MariaDB, Oracle, Microsoft SQL Server, and Aurora for AWS proprietary database. Advantages over using RDS versus deploying databases on EC2. So basically RDS relational database service or system is a managed service. Basically here service not system, sorry for that. So automated provisioning, auto OS patching, so these all are the responsibility of AWS. So here AWS is responsible for automated provisioning, OS patching and continuous backup, restore to specific time stamps and monitoring dashboards, and making read replica for improved read performance, multi-AG setup for disaster recovery, and maintenance windows for upgrade scaling capability, and storage backed by EBS GP2 or IOM. So these all are the basically service provided by the AWS, and here AWS is responsible for the some services, and some services is responsibility, some managing some services is responsibility of users. But when we talk about managed services, then all the services which comes into the managed service category is managed by AWS. So here we cannot able to access such into our instances. So point should be noted is that we cannot access such into our instances. So let's talk about RDS backups. So basically backups are automatically enabled in RDS. So automated backups are daily fully backup of the database during the maintenance window. Transaction logs are also backed up by RDS on every 5 minutes. So we have the ability to restore any point in time from oldest backup to 5 minutes ago. And here backup can be retended in for 7 days, and after that it is deleted, and this time can be increased up to 35 days. Database snapshots. Basically database snapshots are manually triggered by the user, and retention of that backup as long as we want. So RDS storage auto scaling. Let's talk about auto scaling related to RDS. So it helps us to increase storage on our RDS or database instances dynamically. When RDS detects we are running out of free database storage, it scales automatically. It avoids manually scaling our database's storage. You have to set maximum storage threshold, maximum limit for database storage, and we have to automatically modify storage if free storage is less than 10% of allocated storage and low storage test at least 5 minutes. So 6 hours have passed since last modification. So it is basically useful for application with unpredictable workloads. and support all RDS databases engine, MariaDB, MySQL, PostgreSQL, and SQL Server and Oracle. So what is RDS read replicas for read scalability? So we can set up to 5 read replicas within availability zone or cross availability zone or within cross region. So replication is basically asynchronous, so reads are eventually consistent. So replica can be prompted to their own database, and the application must update the connection string to leverage read replica. So here point is noted that here async replication is made between the RDS database instance and between the read replica. So on read replica we can only perform read operation. We are not able to perform here write operation because it is a read replica. So that we can only perform read and write both operations in RDS database instances. So what are the basically use cases of RDS read replicas? So we have a production database that is taking a normal load, and we want to run a reporting application to run some analytics. So we have to create a read replica to run the new workload there. So the production of application is unaffected. Read replicas are used for select read only kind of statements, not insert, update or delete. Okay, let's move further. So network cost of read replicas. In AWS, there is a network cost when data goes from one availability zone to another. It means if we are in same availability zone, then it is free. For RDS read replicas within the same region, we don't have to pay that fee, and also we don't have to pay fee for the same region. But when we try to basically using read replicas in different basically regions, then you have to pay network charges for that. So let's notice a point here. Here same region can be termed as availability zone. Here like we are in US East 1A and it is US East 1B. We are in same region. So and we are also in two different availability zones, but we don't have to pay any fee. Like network cost, we don't have to pay any network cost. But here it is a cross region. We have a RDS database instance in the US East 1A and our read replica is in EU West 1B. So we have to pay the network cost here. So let's talk about RDS multi-availability zone disaster recovery. So here one DNS name is equal to automatic failover to standby. So if our one DNS name is fail, then its DNS name is automatically transferred to a standby instances. Like here illustrated in example, we have some application and it applies read write operation on DNS name. Then when if RDS master database instance of availability zone is failed, then what will be happen? Then is DNS name is going to bind with instance standby, which is in different availability zone. So failure in case of loss of availability zone, loss of network instance or storage failure. So no manual intervention in apps. So and this multi-availability zone replication is free. Note that the read replicas be set up as multi-availability zone for disaster recovery. Okay, so let's move further. So from single availability zone to multiple availability zone. So why we have to move from single availability zone to multiple availability zone? Because zero downtime operation, no need to stop the databases. So just click and modify for the databases, and the following will happen internally. A snapshot is taken, a new database is restored from the snapshot in a new availability zone, and synchronization is established between the two databases. So here what will basically happen? So RDS database instance is basically going to take a database snapshot, and that snapshot is going to store it in somewhere, like it may be stored in AWS or in S3 bucket, and then we restore that as a standby database, and these both are connected with basically a synchronous replication procedure. So let's talk about RDS encryption operations. So basically encrypting RDS backups. So here points should be remembered. So a snapshot of an unencrypted RDS database are unencrypted. Snapshots of encrypted RDS databases are encrypted. So we can copy a snapshot into an encrypted one. So to encrypt an encrypted RDS databases, first of all, we create a snapshot of that unencrypted database, and then we basically copy the snapshot and enable encryption for the snapshot, and we restore the databases from the encrypted snapshot, and in last step we migrate applications to the new databases and delete the old database. Okay, let's move further. So what is RDS security? So basically RDS security is managed by two things. First one is we talk about network security, and we talk about the access management. And these are controlled. Access management is controlled by IAM, and first one is controlled by the network security. So let's talk about network security. So RDS databases are usually deployed within a private subnet, not in public one. So RDS security works by leveraging the security group, the same concept as for EC2 instances, and it controls which IP or security group can communicate with RDS. So let's talk about access management. So IAM policy helps control who can manage AWS RDS through RDS API. Traditional username and password can be used to log into the databases, and IAM-based authentication can be used to log in the RDS MySQL and PostgreSQL. So let's talk about RDS IAM authentication. So IAM databases authentication work with MySQL and PostgreSQL. So here points should be remembered. It can only work with MySQL and PostgreSQL. So we don't need to a password, just an authentication token is obtained through IAM and RDS API to call. So authorization token has lifetime of 15 minutes. So what is the benefits of this? So network in or out must be encrypted using SSL. IAM to centrally manage users instead of databases. We can leverage IAM roles and EC2 instances profile for easy integration. So what are RDS services? Basically, API call, get authorization token, IAM. So here our EC2 instance has assigned IAM role. So my EC2 instance make a call, API call to RDS services and get a authentication token. And all these basically when we get this token from RDS service, then we can communicate with our deployed databases like MySQL, or it may be PostgreSQL, and these tokens are encrypted by using SSL. So let's talk about RDS security summary. So encryption at rest is done only when we first create the database instance, or we have to encrypt. If we have unencrypted database, then we have to make a snapshot and copy that snapshot as encrypted, and we can create database from that snapshot. So what is our responsibility? Check the ports, IP, security groups, inbound rules, and database security group. In database, user creation and permission are managed through IAM. So creating a database with or without public access. So and last responsibility of user is ensure parameters group or database configured to only allow SSL connection. So what is the AWS responsibility? So AWS responsibility is making no SSH allowing, and no manual database patching, no manual operating system patching, no way to audit the underlying instances, because this RDS is a managed service. Let's talk about Amazon Aurora. So basically Aurora is a proprietary technology from AWS, and it is not a open source technology. So Postgre and MySQL are both supported as Aurora database. That means your driver will work as if Aurora was a Postgre or MySQL database. So Aurora is AWS cloud optimized and claims 5 times more performance improvement over MySQL and on RDS, and over 3x more performance than PostgreSQL on RDS. So basically Aurora storage automatically grows to increment of 10 GB up to 64 terabytes. Aurora can have 15 replicas, while MySQL has 5, and replication process is faster than the MySQL RDS. Failover in Aurora is instantaneous, so because it is high availability. So Aurora cost is more than RDS. It is 20% more than simple MySQL or PostgreSQL databases. But it is also more efficient then both MySQL based RDS and PostgreSQL based RDS. Aurora high availability and read scaling. So basically 6 copy of our data across 3 availability zones. 4 copies out of 6 needed for write, 3 copies out of 6 needed for read, and self-healing with peer-to-peer replication. And storage is stripped across hundreds of volume. One Aurora instance stack writes, that is called master, and automatic state failover for master in less than 30 seconds. Master plus up to 15 Aurora read replicas server reads. Support for cross-region replication. So here example is given to understand this. Here we have only one master and we have basically 5 read replicas in different availability zones. So basically this architecture is applied on different availability zones, and this nature is self-healing nature and it can auto expand it. So let's talk about the Aurora database cluster. So when we create Aurora database, we get 2 endpoints. First one is writer endpoint and second one is reader endpoint. So writer endpoint basically point to the master Aurora database, and reader endpoints basically point to read replicas. And they have shared storage volume which can auto expand from 10 gigabytes to 64 terabytes, and 64 terabytes is such a huge amount. Let's talk about features of Aurora. First feature is automatic failover, second is backup and recovery, third is isolation and security, third is industry compliance, fourth is push button scaling, fifth one is automated patching with zero downtime, with advanced monitoring and routine maintenance. So last one is backtrack. Okay, so here we can restore data at any point of time without using backups. Let's move to next slide. Let's talk about Aurora security. So Aurora shares the similar RDS security features because they uses the same engines, and Aurora support encryption at rest using key management services, and it's also have automated backups, snapshot, and replica features that are also can be encrypted, and encryption in flight is supported by using SSL. Same procedure can be followed as MySQL or PostgreSQL. So possibility to authenticate using IAM token, same method as we discussed in RDS section. So we are basically responsible for protecting the instances with security groups, and we are not able to SSH with Aurora. Okay, let's move to next slide. So Aurora replica can be auto scaled, like we have a client connected to from 2 endpoints, like writer endpoints and readers endpoint, and writer endpoint he can write, but if many read requests are coming to for write operation, and CPU utilization of these two Amazon Aurora read replica basically increases, then we have to auto scale our read replica. So read replica basically automatically scale and they share the same storage volume. Okay, and let's start basically understand about Aurora custom endpoints. So basically we can define a subset of Aurora instances as a custom endpoint, and example for running analytical queries and on specific replicas, and the reader endpoint is generally not used for defining custom endpoints. So basically here in this diagram we can clearly say this is the writer endpoint, this is the reader endpoint, and all the analytical queries is goes to our custom endpoint, and this custom endpoint is basically connected to our different basically read replicas. Okay, so let's move on next slide. What is Aurora serverless? So basically Aurora serverless is automated database instantiation and auto scaling based on actual usage. So it is good for infrequent or indeterminate or unpredictable workload. So there is no capacity planning needed, and we can pay per second, can be more cost effective for infrequent or for unpredictable workloads. So basically this is the diagram. Here client connected from proxy fleet, which is managed by Aurora, and rest is managed by the AWS. So they also share the usage, the shared storage volume. What is Aurora Multi-Master? In case we want immediate failover for write node, so every node can perform read-write operation. So here we are not promoting only read replica. Here every node here can work. Basically on every node we can perform read and write both operations. So this is called Aurora Multi-Master. Here every Amazon Aurora database is a master database. No one is a read replica. Okay, they also share storage volume. So let's talk about global Aurora. Aurora can use as a global database. So it is basically useful in cross region read replication and write replication, and also it is useful for disaster recovery and simple to put in place. So Aurora global basically database is recommended in the case of if we have one primary region read or write, and we can basically set up to 5 secondary regions, and there is a replication lag is less than 1 second, and we can basically make up to 16 read replica per secondary region, and it helps for decreasing the latency, and it's promoted another region for disaster recovery as an return time objective of less than 1 minute. Let's talk about Aurora machine learning. So basically it enables us to add machine learning based prediction to our applications by SQL, and it is a simple, optimized and secure integration between Aurora and Amazon Web Services machine learning services. There are basically two types of supported services, which is known as Amazon SageMaker and Amazon Comprehend. Amazon SageMaker is used to make machine learning model, and Amazon Comprehend is used for sentimental analysis. We don't have need to have machine learning experience. Use cases may include fraud detection, ads targeting, sentiment analysis, product recommendation, and many more. Here is a diagram to depict this. Here, our application or user performs some SQL query on our Amazon Aurora, and this Amazon Aurora can generate response based on user request. And here our Amazon Aurora is also connected with the Amazon SageMaker and Amazon Comprehend for machine learning model and or for sentiment analysis. Let's move to next slide. Let's talk about Amazon Elastic Acid. So Elastic Acid is basically a managed cache management system, and Elastic Cache has basically followed two protocols, which is Redis and Memcached. Basically Redis or Memcached is a protocol which is implemented in Elastic Cache, which is used to implement Elastic Cache. So basically cache are in-memory databases with really high performance and low latency. And here it helps reduce load of a database for read-intensive workloads, and it helps make our application stateless. So AWS takes care of operating system maintenance, patching, optimization, setup configuration, monitoring, and failure recovery and backups. Using Elastic Cache, we can involve heavy application code changes. Let's talk about Elastic Cache with solution architect perspective. So basically Elastic Cache is a database cache. So here we have an application and in Amazon Elastic Cache with a Amazon RDS system. So when application basically user requests some RDS data from our server, then this request goes first transferred to the Amazon Elastic Cache. If data is present in requested data is present in Elastic Cache, then it is termed as cache hit, and that data is immediately returned to the application with very low latency. If cache misses occurred, then our application read data from directly Amazon RDS, and also it copy that data into our Elastic Cache. So here our application basically write to cache. So basically this cache is like our basically computer cache memory, so you can think about that. So basically cache must have an validation strategy to make sure only the most current data is used in there. So Amazon Elastic Cache contain only most current data used. Okay, so let's move further. So Elastic Cache for solution architect as storing user session data. So basically user logs into any of the application, and the application write the session data into the Elastic Cache. Okay, basically user is connected to our application, and application write session data into Amazon Elastic Cache. So then user hits another instance of our application. Suppose if user basically we are using if we are using load balancer and auto scaling group, then user can hit any other instances of our application. Then instance can retrieve that session data stored in our elastic cache, because elastic cache contain the latest used information. So this elastic cache can be used to store user session data to make it our application stateful when we are using any stateless protocols. So overall, it in our Amazon Elastic Cache help us to make our application stateless. So basically, two types of protocol is widely used to implement Elastic Cache, which is known as Redis and Memcached. So there is some difference between two protocols. So basically, Redis is a support multiple availability zone with auto failover features, and there is a read replica to scale read and have high availability and data durability using AOIF presence and backup and restore features. And Memcached, whereas Memcached uses the multi-node partitioning features, that is also known as sharding, and there is no high availability, no persistent, and no backup and restore, but it is multi-threaded architecture. So basically, Memcached, if you have if we have to use Elastic Cache with our databases, which is very frequently accessed for read operation, then we can use Memcached. And here, where there is no requirement for persistent storage of that basically cache, because Memcached have multi-threaded architecture, so it is faster than Redis. But Redis have many more features, like it supports multi-availability zone, and it has read replica and high availability features, and Redis is more durable than Memcached, and also it supports backup and restore features. So as per our requirement, we can use Redis or Memcached for implementing our Elastic Cache. So let's talk about Elastic Cache security. So basically, all cache in Elastic Cache does not support IAM authentication. So IAM policy can be only implemented on Elastic Cache for AWS API level security. For Redis Auth, we can set a password or token when we create a Redis cluster, and this is an extra level of security for our cache. It supports SSL in-flight encryption, and when we talk about the Memcached, then Memcached supports SASL based authentication, and SASL is a very advanced authentication method. Let's move further. Patterns of Elastic Cache. Basically, Elastic Cache follow the lazy loading procedure, and all the data is cache that can become stale in cache, and write through adds or update data in the cache when written to a database. So basically, it can store store temporary session data in a cache using TTL feature. TTL is stand for time to live feature. And there is a quote: there are only two hard things in computer science, that is cache invalidation and naming things. Okay, so think about this pattern. Here is a diagram to show the patterns of Elastic Cache. Let's talk about Elastic Cache Redis use cases. Suppose you have to make a gaming leaderboards, which is very computationally complex because we can have millions of basically users that are playing games. And here ready sorted sets guarantee both uniqueness and elements ordering because it is a persistent and highly available elastic cache. So basically each time a new element is added, it is ranked in real time and then added in correct order because many of the users can play that game on different times but they have different scores. So we have to done this ranking in real time, and we have to also ensure that the ranking order must be persistent and in right way. So like here, if many of the clients basically store their rank in the elastic cache, and elastic cache only store the highest rank available at per time basis. So basically here we are ranking in real time, and on the basis of this elastic cache stored data we are making a real time leaderboard. Okay, so basically this is a simple use cases of Redis. Okay, so let's some practice our hands-on on the RDS. So let's move on to our console. So let's search here for RDS, and here is RDS, which is basically managed relational database services. So let's create a database. So click on create database, and here we can click on standard create or easy create. So for here I am to demonstrate all the steps to create that database. So I choose the standard create, and here I take basically my SQL example because my SQL is compatible with free tier, and here we are going to use free tier. So some of the features may be not present in free tier, but I am here to only demonstrate that. So here we can use a password, like here master username is admin and master password I can write here. So basically I here used password, and basically here it is used a T2 micro. It means we are running our database on T2 micro instance, and here is basically storage type. Here GP2 is used for storage. We can select IO1 or magnetic. So let's allocate storage. Here I am allocating only 10 GB storage because here we are only demonstrating it, and we can also able to make a snapshot. So here maximum storage threshold is set to 1000. So here we can configure the default VPC. So here I am using default VPC, and subnet group is also set to default. Either this basically RDS or database is going to publicly accessible or not. So here it is tick to no. If you want to make it publicly accessible, then we can click on yes. So like I click yes, choose VPC security group. So I choose a VPC default security group, and here we can choose basically 1A or 1B, any availability zone which is available. So here database authentication have three features: password authentication, password and IAM database authentication, and password and Kerberos authentication. So here we can set additional configuration information, but I left it blank. So here we can set database initial database name, and enable automated backup is enabled by default, and backup retention period is basically set to 7 days, and we can increase it up to 35 days. So here it is 35 days. So let's we proceed with basically default setting. Here we can also enable enhanced monitoring, but it charges. It is not comes into critical, so we are not enabling it. And here are the many of the features are also available. So let's create databases. So here it says password does not match. So I re-enter my password. And let's try to create database. This time my database is created, and now we can access this database with some tools, like we can use SQL electrons or many more. And also here we can make a snapshot of this database, like if we select it and we go into actions. Here we have only features of delete is enabled because it is not created, and it is now in the status of creating. When it is created, we can make a snapshot from that database, and we can restore it when it is needed. So like if you want to access these databases, then you can use tools like community based tools like SQL Electron, and also SQL Electrons come for Windows and many more platforms. So this is the basically official page of SQL Electron, from where we can download and use it. Basically I am not going to deep dive in it, so that's why I am only showing these features of RDS. So here my RDS is in creating status. It can take time. So let's check one more time, is our RDS is created or not. So it's taking time, so I pause my video. So here our database is now in available states. So here we can check the action options. So here we can stop our basically database instance, or reboot it, or we can simply delete it, or we can create a read replica. Here we can take a snapshot, and because my database is not encrypted by default, and I not basically encrypt it when I defining it. So here our snapshot is also not encrypted, but we can encrypt it by using the snapshot copy features. So basically here we can make a snapshot name like demo snap, and here we can take a snapshot of our instance, and here we can store it, okay, in either in S3 bucket, or either in basically EBS volume or EFS volume. So here I already created a database snapshot. So here we can see the all options which are present. So here we can restore from snapshot, and here we can copy our snapshot, or here we can export it to Amazon S3, or here we can delete Amazon, basically delete that snapshot. So here I am not going to use, I want to only show the option how we can do that. If you want to store your snapshot, then you can use restore snapshot. We can click on restore snapshot, and this is completely going to restore your snapshot. Okay, so here I am not going to do that, and here I am deleting all this snapshot, because these snapshots are just for demo purpose. There is no use of this snapshot. So here because this snapshot is now in creating status, so we can not able to perform any action. So let's go back, and here is our database one is now backing up. So basically in this hands-on we use a MySQL community engine. We can use any engine, but free tier is only compatible with MySQL community and PostgreSQL. Okay, so basically here we can delete this database. Okay, so to confirm the deletion, we have to type delete me here, and after typing delete me, we can delete that snapshot. So this snapshot is deleted, but here there is in progress of creating a final snapshot. So first of all, this operation is going to complete, then only the deleted operation is going to complete it, because here status is deleting, it is not deleted, it's deleting. Okay, so always remember that, because this process are go into a queue. Okay, so let's move further. Let's talk about Route 53. What is Route 53? Basically, Route 53 is DNS management system. Okay. So, question is, what is DNS? Basically, DNS is stand for domain name system or domain name, which translate the human-friendly host name into the machine IP addresses. Like when we type www.google.com in our browser, then this domain name is going to translate into the equivalent IP address. And basically we can think DNS as a backbone of the internet, because we are not able to remember that numeric system, and we can easily remember this www.google.com. So here DNS uses a hierarchical naming structure. Here .com is a top level domain, and here example is our domain name, and here basically not a domain name, because domain name make this is the domain. So and here www is locating its on this domain on World Wide Web, and here is a example of subdomain which is api.example.com, like aws.amazon.com. so here AWS is a subdomain of basically amazon.com. So let's talk about the DNS terminology. Okay, first one is we can think root 53 as a domain registrar, like we can register our domain on route 53, GoDaddy, and on Google Domains, on Hostinger, and many more domain registrar are also present in present on internet. And let's talk about DNS records. Basically, DNS record are many types, but we widely used A record, for A record, CNAME, and NS records, and also alias record in AWS. So basically, what is A record? A record directly bind with the IPv4 address, and for A record directly bind with the IPv6 address. And what is CNAME record? And CNAME record bind with our domain name. And what is NS record? Basically, NS is stand for name server, so it's basically point to our name server, and its name server record is given by the hosting providing server, and we have to put this NS record into our domain registrar, basically NS record panel, in NS record panel. So let's talk about what is zone file. Basically, zone file contains the DNS record. Basically, name server resolves DNS queries, which is authority or non-authority. And here TLD level domain like top level domain are .com, .us, .in, .gov, .org, and SQL level domain is like amazon.com, google.com, etc. So here, if we talk about the root, then dot is known as root, and top level domain is com.com, and here second level domain is basically .example.com, and here subdomain section content like www. But here we can place anything like basically api.aws.example.com, basically api.aws.amazon.com, and this is called subdomain. And this whole section make a domain name. After combining, this whole section make a domain name. And here what is HTTP? Basically, HTTP is a protocol which is used to make a request from our server. Here it may be FTP, SFTP, and many more, and like HTTPS. So this whole section make a fully qualified domain name. Okay, so always remember these all terminologies. So here is an example given how DNS work. So basically, we have a browser and we want to access example.com. Then our request first go, basically first of all our request resolve locally, and then it search on web server what is the IP address of this example.com. Then web server return that example.com is located in that IP address, and this IP address is basically transferred to the local DNS server, and then local DNS server transfer that request to the basically root server, and then root server return basically these root DNS server are managed by ICANN, which is a basically international regulatory, and then this NS record is a top level NS record is returned by the root DNS server, and then he make a request to basically top level domain DNS server, and then he response from that NS record is located on that location, and then after he make request from second level DNS server that return the basically exact IP address where the our basically the domain name system is located. So by using this manner our basically domain name resolved to the exact IP addresses. So there are some any other procedure may be also, and some any other regulatory bodies can also involve, like first of all our request is resolved locally in our host file. So if we block or if we give that example.com to another IP address in our local host system, then it is not going to make that request. It is only translated to example.com to a specified IP address. So let's move further. Let's talk about Amazon Route 53. So basically Amazon Route 53 is a highly available, scalable, fully managed and authoritative DNS. Authoritative means customer can update the DNS records. Okay. So Route 53 is also a domain registrar, like we can register any domain name with Route 53, and there is ability to check the health of our resources. The only AWS services which provide 100% availability with policy. Basically this is known as service level agreement. So basically it is a policy that says only one AWS service provide 100% availability, that is Route 53. So always remember that point. So why Route 53 is used? Route 53 is a reference to the traditional DNS support. Okay. It means Route 53 uses all the traditional DNS ports, like for SSL it uses 443, and for HTTP it uses basically port 80, and for FTP it uses port 21, and many more. Here, like if we make a request of example.com, who is example.com, then Amazon Route 53 return the exact IP address of that example.com, and now client can communicate with that IP address. So here when we ask from Route 53 who is example.com, then he return an IP address as an identification, because IP address is a unique identification number. So that's why by using this number we can locate that basically internet connected resources. Here in our example is EC2 instance. So let's move further. Let's talk about Route 53 record. So basically each record contains domain, subdomain name like example.com, or it can contain IP addresses. So record type may be A record, CNAME record, 4A records, aliases, and many more. And value may be some IP addresses or some NS records. And what is routing policy? So basically Route 53 uses routing policy to respond the queries, and TTL is stand for time to delay. and it is a amount of time the record is cached at DNS resolvers. And Route 53 support the following DNS records type. It support basically A records, 4A records, CNAME, NS. This record is the most known record because they are widely used, and some advanced records are also supported by Route 53, which is CEA, DS, MX, NAPTR, PTR, SOA, TXT, SPF, SRB, and many more. So basically, let's understand some widely used record types. So what is A? A records maps to a host name to a IPv4. Whenever we request example.com, then A record come into play and map that host name to the equivalent IPv4 address. And what is 4A records? So basically, it maps a host name to IPv6. First one is for IPv4 and second one is for IPv6. Then what is the basically use case of CNAME records? Basically CNAME maps a host name to another host name. It means it's mapped to another host name. Like example.com have some NS records. Then these NS records are also equivalent to some another hostname records. Okay, we cannot create a CNAME record for the top node of a DNS name space. Okay, so always remember that we cannot create a CNAME record for the top node of a DNS. So what is NS? Basically name servers for the hosted zone. It might be not clear here, but when we do hands-on, then it is more clear. Basically NS records control how traffic is routed in our domain. Okay, let's talk about Route 53 hosted zones. Let's talk about Route 53 hosted zone. Basically, it is a container for records that define how to route traffic to a domain and its node domain. So basically, public hosted zone are contain records that specify how to route traffic on the internet. And private hosted zone contain records that specify how you route traffic within one or more VPC. And you have to pay $0.5 per month per hosted zone. Okay, so let's move further. Route 53 public versus private hosted zone is depicted by this figure. Okay, so here we search for example.com and Route 53 return that IP addresses. So behind the scene, what he do? So behind the scene, they can follow the same procedure, and our client then can directly communicate from here. But when we are using private hosted zone, then only the private instances can communicate from our hosted zone. Like no any other client from outside can make a request from our private hosted zone, and you are not basically able to make a connection from our private hosted zone because it is within a VPC. Okay, so let's talk about the Route 53 record TTL's time to live. Okay, so we can set our TTL to 24 hours if we have less traffic on Route 53, and possibly we get a outdated record. If we set low TTL or low time to live, like we set 60 seconds, then we expect more traffic on our Route 53 and it increases the cost. And also but there is an advantage of that. Our records are outdated for only 60 seconds. Okay, so it is easy to change records, and except for alias record, TTL is mandatory for each DNS records. Okay. Let's move further. So here is an example is given. You can try to understand it and based on this explanation. So what is the difference between CNAME versus alias? So like AWS resources, load balancer, CloudFront, S3 and many more. Basically it's exposes in AWS hostname, which is like if we talk about the load balancer, then it is this, and if you talk about CloudFront, then it may be. So like if we have a load balancer address this and we want this domain. So what is the basically difference between the CNAME and alias? So basically CNAME points a host name to any other host name. Like app.mydomain.com can be translated to any other domain, and it can be only for non-root domains. It can be only set for non-root domain. Okay, like .ak something.mydomain.com, but alias record can be set to both root domain and non-root domain. So this is the basic difference. CNAME record can be only set for non-root domain, but alias record can be set for both root domain and non-root domain, and it is a free of charge. And whenever CNAME record is not free, okay, always consider that point. Let's talk about root 53 alias records. So it's map a host name to an AWS resource, like example.com is basically maps with my ALB. So this is the address of my ALB. Okay, and this is the basically host name of my elastic load balancer. So basically it automatically recognizes change in our resources IP addresses, and unlike CNAME, it can be used for the top nodes of a DNS namespace, like for example.com. And alias record is always of type A or 4A for AWS resources. We are not able to set the time to live record on TTL. Okay, so let's move further. Root 53 alias record targets. So basically targets may be elastic load balancer, CloudFront distribution, API gateway, elastic beanstalk environments, S3 website, VPC interface endpoints, and global accelerators, and a root 53 record in the same hosted zone. We cannot set an alias record for an EC2 DNS name. So here point should be noted. We are not able to set an alias record for a EC2 DNS name. Let's talk about root 53 routing policies. So root 53 routing policies define how root 53 respond to the DNS queries. So please don't get confused by the word routing, because it is not the same as load balancer routing, which routed the traffic. Basically DNS does not route any traffic, it only responds to the DNS queries. So it is the only responding way. So root 53 support the following routing policies, which may be simple, weighted, failover, latency based, geolocation, multi-value answer, and geo proximity. So let us discuss this point. So what is simple routing policy? It basically route a traffic to a single resources, and we can specify multiple values in the same record. If multiple values are returned, a random value is chosen by the client. So when alias enabled, specify only one AWS resources. So it cannot be associated with health checks. Okay, so here if we follow the single basically simple routing policy, then here our basically request is our client make a request from route 53, and route 53 return the IP address, or basically IP record of that domain. So when we set a multiple A record, so here when our client make a request like forward.example.com, then here multiple addresses is multiple A record is returned by the Amazon route 53, and here client can choose a random value, like client can choose 11.22.33.44 and any value from this. Okay, so let's move further. Let's talk about weighted routing policy. So basically it controls the percentage of the request that go to each specific resources, and it assign each record to a relative weight. It may be calculated by using this, but it is too complex. So DNS record must have the same name and type. It can be associated with health checks. Okay, so use cases may include load balancing between regions, testing new applications version, and many more. Assign a weight. We can assign here a weight from 0 to a record stop sending traffic to a resources. So here we can assign weight 0. If we assign weight 0 to any record, then here no request is forwarded to that resource. Okay, if all records have weight 0, then all records will be returned equally. So these 2 points is a rememberable point. Okay, so here Amazon route 53, if we set 70% weight to this EC2 instance and 20% to this and 10% to this, then 70% of overall traffic is goes to this EC2 instance and 20% to this and 10% to this. So it is very simple to understand. So let's move further. So let's talk about latency based routing policies. So first is of all, it redirect to the resources that has the least latency close to us, and it is super helpful when the lower latency is the priority of user, and it is latency is based on traffic between users and AWS region. Like Germany users may be directed to the United States if that is the lowest latency, and if you are in India and we are using latency based routing policy, then our basically request can be transferred to the basically Mumbai Pacific region for lowest latency. Okay, and it can be associated with health checks, so it has automatic recovery from failure. Okay, it has capability to automatically recover from failure. So let's talk about the Route 53 health check. So basically HTTP health checks are only for public resources. They cannot be performed on private resources. Okay. So here health checks may be divided in some types like health check that monitor an endpoint, and health check that monitor other health check, and health check that monitor CloudWatch alarms like throttling of DynamoDB, alarms on RDS, custom matrices, and many more. So health checks are integrated with our CloudWatch metrics. Here we have a demo example. Like we are using Amazon Route 53 latency or geo proximity based routing policy. So here health check can be connected from both basically application load balancer, and it is connected within a same availability zone, like not same, from different availability zone or from different regions. So basically this is the basic fund of health checks. Let's talk about health check that monitor an endpoint. So about 15 global health checkers will check the endpoint's health, and healthy or unhealthy threshold is set to 3 times by default. So like if 3 times reported for healthy, then it is termed as healthy, and if it is continuously 3 times reported as unhealthy, then it is termed as unhealthy endpoint. So basically interval is 30 seconds, we can set it 10 seconds, but it increases our cost. It supports the protocol like hypertense transfer protocol, hypertrace transfer protocol, secure, and transmission control protocol. If greater than 80% of health checkers report the endpoint is healthy, then Route 53 consider it healthy. Otherwise, it is considered as unhealthy. Basically, here is ability to choose which location we want to feed Route 53 to use. And here is a health check pass only when the endpoint respond with like 200, 212 or something which is started from 2 and 3 status code. Like if it's respond to 200 OK and 300 OK or 302 OK and many more which started from 2 or 300 basically request response. Health check can be set up to pass or fail based on the text in the first 5220 bytes of the responses. So we can configure basically router or firewall to allow incoming request from Route 53 to health checkers. Okay. So let's discuss about the calculated health check. We can combine the result of multiple health check into a single health check, and we can use or and or not operators, and we can monitor up to 256 child health check under the umbrella of single parent. So we can specify how many of the health check need to pass to make the parent pass. And users can perform like users may include like performing maintenance to our website without casing all health checks to fail. Here in the given figure we can clearly see that. Okay, let's move further. Health checks for private hosted zones. Here Route 53 health checkers are outside the VPC, so they cannot access private endpoints. So we can create a CloudWatch matrix and associate a CloudWatch alarm, then create a health check to that check alarm itself. So let's talk about routing policy, which is failover policy. So basically when our client requests some DNS request and This instance is marked as unhealthy by health check. So basically here health check is a mandatory, so we cannot skip a health check here, so that's why it is a mandatory, because here we are using failover policy. So for checking the health of the primary instance, you have to you must have a health check. Okay, so if this health check reported as unhealthy, then or if any failure is happened, then our request is transferred to that second EC2 instance. So basically this is very useful in disaster recovery. Let's move further. So let's talk about geolocation routing policy. So basically routing policy, geolocation routing policy is different from latency based policy. This routing is based on user location. It specifies location by continent, country or by states. If there is overlapping, most precise location is selected. We can create a default record in the case there is no match on location. Use cases like website localization, restricting content distribution, and load balancing. It can be associated with health checks. So let's move further. Geo proximity based routing policy. So it's route traffic to our resources based on our geographic location of users and our resources. So the geo proximity policies have ability to shift more traffic to resource based on the defined bias. To change the size of the geographic region, we can specify the bias value. Like it can be expanded from 1 to 99 for more traffic to the resources, and it can be shrink to -1 to -99 for less traffic to our resources. And here resources can be AWS resources, where we can specify AWS regions, and non-AWS resources specify latitude and longitude. So you must route 53 traffic flow to use this feature. Like if we make a geo proximity policy and we divide basically our whole resources in two parts, and that first one is we have like to basically bias value set with 0 and region and availability zone US East 1, and second is US West 1. So we have like different region, or it can be also set based on basically availability zone, but availability zone within the same region, so it not matters a lot. So it is a region specific. So here when user closes to basically US West 1 make any request, then her request is goes to that resources of US West 1. And here if basically these resources basically this user request is goes to resources of US East 1, because they are geo proximate to that region. So if we set higher bias in US East 1, so what will be happen? If we set higher bias in US East 1, then it get more traffic because its geo proximity is enhanced. So this is the difference of the bias value. Here we have the same bias value, like here bias value is set to 0, or if we give the same bias value, then it follow the same basically routing policy. So let's move further. What is Route 53 traffic flow? So it simplifies the process of creating and maintaining records in large and complex configuration. So we can use visual editor to manage complex routing decision tree. Configuration can be saved as traffic flow policy, and it can be applied to different Route 53 hosted zones in different domains, and it supports versioning. Let's move further. So what is multi-value routing policy? Like it is used when routing traffic to multiple resources, and Route 53 return multiple values or resources. It can be associated with health checks, return only value for healthy resources. Up to 8 healthy records are returned for each multi-value query. Multi-value is not substitute of having an elastic load balancer. Okay, so here for the same host name we set different records with different values. Like here value IPv4 address is 192.0.2.2, and here is different and here is different. So this is the basic concept of multi-value routing policy. So let's understand the difference between domain registrar and domain name system or domain name server services. So basically we can buy a register or domain name with any domain registrar, typically by paying annual charges, like from GoDaddy, Amazon registrar, Google domains, Hostinger, and many more. The domain registrar usually provides you both with a DNS service to manage our DNS records. So we can use a further DNS service to manage our DNS records. Example, purchase to domain from GoDaddy and use Route 53 to manage our DNS records. Let's move further. So here we want to set up basically a domain which is basically purchased from GoDaddy. So GoDaddy is here termed as registrar and Route 53 as a DNS service. Because we are hosting our services on AWS, so basically we create a public hosted zone on our Amazon Route 53. So we have to copy that name server records into the basically records of GoDaddy. So these records are basically copied into the name servers records of our GoDaddy or our domain providers. Because our domain provider is GoDaddy here and our hosting provider is basically Amazon AWS. Okay, let's move further. Third party registrar with Amazon Route 53. So if we buy our domain on a third party registrar, then we can still use Route 53 as the DNS service provider. We have to create a hosted zone, a public hosted zone in root 53, and we have to update NS record on third-party website to use root 53 name server. Here domain registrar is not equal to the DNS service provider. Okay, but every domain registrar usually comes with some DNS service features. Okay, like GoDaddy provide also domain and hosting both, and Hostinger provide also domain registration and also hosting services, and AWS Route 53 also provided the domain registration and hosting services. Okay, so let's move further. So before discussing about classic solution architecture, I want to illustrate some basic hands-on this on this Amazon basically Route 53. So let's move to our Amazon console. So let's get started with Amazon Route 53. So click on get started. So here we have a lot of options like we want to register a domain or transfer a domain or create hosted zones or configure health checks, configure traffic flow and configure resolvers. So here first of all I want to demonstrate basically how to create hosted zone. So here when we click on get started, here we can basically set a name, and basically this hands-on is not free because when we create a Route 53 hosted zone, then we have a monthly charges to create each hosted zone. So here some of the option is present, like we want to create public hosted zone or private hosted zone, as I discussed in last session. So in this manner we can create hosted zone. So I am not creating any hosted zone because of it not come with prettiest, and I am covering all the hands-on which comes within the free tier. So I did not create any hosted zone. So these are the basically options which are available, like Route 53. When we come to Route 53 dashboard, we can create hosted zone, we can create traffic policy. Like when we click on create policy, then here we can give name to our policy, like if we want to name like Timo policy. So here it is version 1, so description is optional and we can click on next. So what is the DNS type? IPv4 address or IPv6 address, or it is a CNAME, or it is a MX record, or many more. We can connect it to with the policy like failover rule, geolocation rule, weighted rule, latency rule, and multi-value answer rule, geo proximity, and new endpoint. So these are the rules from which we can connect. Like if we click on weighted rules, then so here I selected weighted rule. So here we can set some weight, and here I say 50 and here I say 50. So I basically equally distributed my weight, and we can connect it to the from endpoint. Like endpoint, maybe it is S3 or it is any like CloudFront or any other. Like here option is given CloudFront distribution, Elastic Beanstalk, ELB application, load balancer, ELB classic load balancer, and network, and S3 website endpoint. So if you want to add with S3 website endpoint, let here. So here we can connect it also with some another endpoint, and we can create traffic policy. So I am not creating here any policy, I just demonstrate it to how to create any policy. So let's cancel this, and let's explore other options which are available. So here also option available of availability monitoring. So here we can create health check, and here if you want to register any domain, because Route 53 is also work as a domain registrar, as I discussed in some previous slides. So here we can basically search for a domain, like if you want to take a domain takeej.com, then here we can check it either it is available or not. So here basically takeej.com is unavailable, and many more are available. So by here adding it to cart, we can buy it. So you can explore here for more options. So basically I am not buying, I am only demonstrating what are the basically features available of Route 53. So let's back. So let's create a health check. So here we can give a name to our health check, and which endpoints I want to monitor, like I want to monitor a endpoint, or I want to monitor status of other health checks, or let's here we give a name demo SC, and we want to monitor endpoint, and here we want to monitor a domain name. Let's suppose domain name is www.takeej.in, and port is 80, and we can also specify path, but here I am not specifying path, so we can click on next. And here in step 2 we have to basically get notified when health check fails. So it is by default set to no, we can set it to yes, and we can create a alarm, which is basically topic may be existing SNS topic, or we can create a new SNS topic. So by default it is set to no, and here after clicking create health check, we are able to create a health check. So let's cancel it. So back here, back. So we explore all the basic features of Route 53. So let's move to new slide. So let's discuss some classic solution architectures. So here we cover basically some samples websites and their architecture. So these solution architectures are the best part of this course. So let's understand how all the technologies work together. So let's move further. Here first of all we are going to develop stateless web app, which is known as whatisTheTime.com. So basically whatisTheTime.com allows people to know what time it is, and we don't need a database. We want to start small and accept downtime, and we want to fully scale vertically and horizontally, no downtime. So let's go through the solution architect journey for this app. Let's proceed. So here we can make stateless web app. So if some user query what time is it, then our basically web web server response time, or our T2 micro response time. It is 5:30 p.m. So basically here this is the most simple architecture. Our server gave the response. Here we don't need to manage any database. Okay, let's suppose our basically web app is scaling vertically. So what happened in previous slide? We are using T2 micro or any T2, and here we have to need to scale vertically because our user is increases. So here more user search what time is it, what time is it. So it increases the overall traffic for our EC2. So here we increase it, here we scale it vertically. It means we change the basically instance type from T2 to M5. Okay, so here we can face some downtime while we are upgrading to M5. Okay, so what happened when our traffic is increases more and more? So basically here it's time to scale horizontally, because if we scale only vertically, then there is some hardware limits. But here when we are scaling horizontally, so it's also known as elasticity, then we are able to give response to as many users as come. So here we create 2 more M5 instances, and we can connect it with the elastic load balancer. Okay, so this is the basic idea behind the horizontal and vertical scaling. So in this manner we can use it. So here we some user query basically using API for whatisTime.com, and then root 53 basically gave the address to user to communicate from our M5 instances. And here we can also use load balancer, as here we are basically illustrated here. So here user query from root 53, and root 53 gave the basically its search, it gave the IP address of this elastic load balancer, and here elastic load balancer transfer those requests to their connected M5 instances. So here we are using root 53 elastic load balancer and EC2 instances. So here our user, we have many of the users, and they are connected, they are searching for whatisTime.com. then first their request is goes to like search engine, and search engine have the index of website, and first of all their request go to the root 53, and then he get the basically IP of load balancer. He did not get directly IP addresses of these instances. He basically get the IP addresses of these users, get IP addresses of this load balancer, so that their request is goes to elastic load balancer, and then load balancer distribute the whole traffic as per her policy. Okay, so let's move on to new slide. So here we are using basically a auto scaling group, because if our some of the availability zone is filled, like here if we here we use a single auto scaling group and single availability zone. But what we will done, if this availability zone goes down, then our whole system is going to down. So for high availability, we also use auto scaling group with multi-AG. So here we use 3 availability zones and 2 instances per availability zone, and we use elastic load balancer to load balance it. This all. So here when user traffic basically goes to route 53 and route 53 give the address to user to this elastic load balancer address. So all the users comes to elastic load balancer, and elastic load balancer basically distribute the whole traffic between these auto scaling groups and between these instances. Okay, so let's move further. So here in this lecture we will discuss public versus private IP addresses in EC2 instances, and elastic IP versus route 53 versus load balancer, and route 53 TTL, A records and alias records, and maintaining EC2 instances manually versus auto scaling group, and multi availability zone to survive disaster, and elastic load balancer with health checks and security group rules, and reservation of capacity for costing savings when possible. And we are considering 5 pillars for well architected application like cost, performance, reliability, security, and operational excellence. So let's move further. So let's talk about a new stateful web app called mywordpress.com. So here we are trying to create a fully scalable WordPress website, and we want that website to access and correctly display pictures which are uploaded to it. So our user data and the blog content should be stored in a MySQL databases. So let's see how we can achieve this. So here first of all we can use RDS with multi availability zone. So this mywordpress.com be implemented with the RDS with multi availability zone enabled. So here user basically request from route 53 to get the IP address of the ALB, which is a multi availability zone of elastic load balancer, and ALB has the address of this basically address of this auto scaling group, and this auto scaling group contains basically 3 instances in 3 different availability zones. Okay, and these may be connected with RDS multi availability zone. Okay, let's move to new slide. So here we are implementing mywordpress.com with auto scaling with Aurora multi availability zone with read replicas. So here we did not have to do, but only we have to implement the Aurora MySQL with multi availability zone read replica enabled. So here first of all user response from route 53, and route 53 gave the IP address of elastic load balancer, and elastic load balancer contains the basically auto scaling group, and in auto scaling group we have 3 different instances in 3 different availability zone, and they are connected by Aurora MySQL with multi availability zone read replica. So let's we want to store images with EBS volume. So there is a simple architecture. We can directly connect EBS volume with our instances. So after connecting our EBS volume, we can store those images in EBS, but we can also store that images in on multiple EBS. So let's suppose we have two EC2 instances in different availability zone. It may be in within the auto scaling group, but here I did not mention auto scaling group. So here we can connect EBS volume from each of our instances, and we can store those images into that EBS volumes. So here we can also use a single EFS volume to store our images. Let's suppose here user get the IP address of basically load balancer, and the user send images to load balancer, and then load balancer forwards him to instances. So here instance store, basically these instances store those images into a EFS volume. Basically EFS is elastic file system, and EFS can be connected with the more than one EC2 instances. So here we are using elastic network interface to connect to basically EFS from our instances, M5 instances. Okay, so let's move on to next slide. So in this lecture we basically discuss about the Aurora database to have easy multi-availability zone and RAID replicas, and storing data in EBS single instance and multiple single instance application, but we can store it in EFS in distributed application manner. So let's move on to new slide. So here basically we launch a full stack EC2 EBS RDS. It can take time to install application and insert initial recovery data or configure everything during the launch, the configuring everything and launch the application. So we can take advantages of the cloud to speed data. So here if you want to basically achieve this previous architecture, then we have to difference. Basically first of all we have to create the instances, and we have to create basic instances in different availability zone, and we have to attach these instances with auto scaling group, and this auto scaling group can be connected with the elastic load balancer, and our load balancer is connected to our route 53, and here we have to configure elastic network interface EFS. All we have to configure in separate manner. So what we can do these all things in one step? Yes, answer is yes. Cloud gave features to do all these tasks in one step just. So this is where the basically elastic beanstalk come. So okay, so let's discuss some more architectures. Like here is a architecture which is basically a complex architecture. Here just it is not too complex, but it is a complex. Here we have route 53, we have multi availability zone enabled elastic load balancer, and here we have auto scaling group, and here have different availability zone instances in different availability zone, and here we are using elastic cache and Amazon RDS. So what is here we are doing? So basically we are storing the cache or session data within the elastic cache. to speed up or to make our basically application stateless. Okay, so here basically user communicate from route 53 and route 53 give the address of elastic load balancer, and user then directly can communicate with the elastic load balancer. And here elastic load balancer basically forward the request to auto scaling group, and in auto scaling group we have the different instances in different abilities, and these all instances are basically can communicate with RDS and Elastic SA. So basically they are connected with the Elastic SA, and Elastic SA is connected with Amazon RDS, and this Elastic SA contain the session data plus can contain cache information. So it overall reduces the basically read write of total read write of total load. It basically Elastic SA reduces the total load of Amazon RDS. So these are basically route 53 and ELB is in public subnet, where our auto scaling group is in private subnet and it is in data subnet. Okay, so let's move further. So what are the basically developers problem on AWS? So here we are managing a huge infrastructure separately, and we are deploying code, we are configuring all the databases, load balancer, auto scaling group, etc. We have scaling concerns, and most of web application we have the same architecture like auto scaling load balancer plus auto scaling group, and all that. So every time we want to make the same architecture, we have to basically we have to make all these things separately. So all the developers want each for their code to run, so possibly consistently across different application and environment. So we have to usually we have to make same architecture for possible solution. Like if you want to deploy a WordPress website, then in most of the cases we follow the same architecture. Although we follow same architecture, but until that we learn only the method to create these auto load balancer separately and auto scaling group separately. But any easiest method is available, or one-step method is available to create that resources? Yes, answer is yes. Basically cloud gave the features, AWS gave the features known as elastic beanstalk. So what is elastic beanstalk? So basically elastic beanstalk is a developer-centric view of deploying an application on AWS. It uses all the components we have been seen before. So like EC2, auto scaling group, elastic load balancer, RDS, etc. So basically it is a managed service. It automatically handles capacity provisioning, load balancing, scaling, application, health monitoring, instance configuration, and many more. So just the application code is the responsibility of the developer. Okay, we still have full control over the configuration. So Beanstalk is free, but we pay for the underlying instances or resources which we are using. So let's move further. So here elastic beanstalk, here is the some components of elastic beanstalk. First one is application. So application is a collection of elastic beanstalk components like environment, versions, configurations, and many more. So application version can contain an iteration of our application code. So what is environment? So environment is a basically collection of AWS resources running an application version, only one application version at a time. What is tiers? Basically tiers, web server environment tier and worker environment tier. So there are two tiers, basically web server environment tier and worker environment tier. We can create multiple environment like dev, test, prod and many more. So here we create application and we upload version and launch environment, and we can manage environment and we can update version, and then we can deploy a new version and we can manage it in cyclic form. Okay, so let's move further. So what are the languages or platforms supported by the Elastic Beanstalk? So basically Go language, Java Software Edition and Java with Tomcat.NET, for Linux, .NET for Windows Server, Node.js, PHP, Python, Ruby, Packer Builder, Single Container Docker, Multi-Container Docker, Pre-configured Docker. It is all supported by the Elastic Beanstalk. Okay. If any technology is not supported by Elastic Beanstalk, then you can create your custom platform. It is only for advanced user. Okay. So let's further and know the difference between web server tier versus worker tier. So here first one is web environment and second one is worker environment. So in web environment we have basically a elastic load balancer which is connected to auto scaling group, and this auto scaling group can scale on different availability zone, and that availability zone contains some EC2 instances. So this is the basic web environment of Elastic Beanstalk. Let's discuss a worker environment. So in worker environment we send our request to SQS, and here our auto scaling group pull messages from this queue. Okay, this SQS queue. SQS is stand for simple queue service, and here basically pull message can be go to basically directly EC2 instance worker instances, like this worker instance belongs from some auto scaling group. So we can say this pull message is go to this auto scaling group, and this is not directly go to auto scaling group. This is basically going to the EC2 worker instances. So if we see high level view, then we can see these pull messages are going to auto scaling group, but in actually it is not going to auto scaling group, but it is actually going to EC2 worker instances. So why this is called worker environment? Because here pull message it goes to the EC2 instances, that's why they called workers. So they also SQS can also pull messages to different availability zone, like here some SQS messages is goes to this EC2 instance, and this EC2 instance belong from different availability zone, and this EC2 instance belong from different availability zone, and it scale based on the number of SQS messages. So we also make this auto scaling group. We can make auto scaling policy based on this, based on the number of queues in these SQS messages. Okay, we can push messages to SQS queue from another web server tier. Okay, so let's move on to next slide. So let's talk about a very important topic, which is S3 storage and data management. So what is S3 storage and data management? So S3 is basically stand for simple storage service. So let's introduce from S3. So Amazon S3 is one of the main building block of AWS. So that's why I say it is so important topic. It is advertised as infinitely scaling storage. Okay. So there is no upper limit to store data here. It is widely popular and deserves its own section. So many websites use Amazon S3 as a backbone. So many AWS services uses Amazon S3 as an integration as well. We will have a step-by-step approach to learn the S3. So let's begin. So let's talk about some overview information about S3 bucket. So what is S3 bucket basically? So Amazon S3 allows people to store object files in bucket, or buckets can be also termed as directories. Bucket must have a globally unique name. Why? We can discuss it later. So bucket must have a globally unique name. Buckets are defined at the region level, and the naming convention are like no uppercase letter, no underscore, 3 to 63 characters long, not an IP, must start with lowercase letter or number. So these are the some naming conventions of bucket. So let's move on to next slide. So object files have a key. This key is a full path basically. What is key? Key is the full path. So S3 colon dash dash basically slash slash my bucket slash my underscore file dot txt is a key, and here it is also a key. The key is composed of prefix plus object name. So here two fields we can clearly say here this is the basically what object name. This is the basically object name, and this is the prefix, and this is the fixed URL which is S3 my bucket. My bucket can be any name. So there is no concept of directories within bucket, although the user interface will trick you to think otherwise. So just key with very long names that contain slashes. Okay. Let's talk about some other important points related to this Amazon S3. So here object values are the content of the body. So maximum object size is 5 terabyte. It is 5000 GB. And if uploading more than 5 GB, we must use multi-part upload feature. Metadata. Metadata is a list of text key or value pairs or system or user metadata. So metadata is basically a data about data. Like if you are uploading image, then image name, alt text, and image creation time. These all are called metadata. So tags. Any code key or value pair up to 10, we can add up to 10 tags, and it is very useful for security and lifecycle management. What is version ID? If versioning is enabled, then we have a version ID embedded with every object. Okay, let's move further. So let's discuss a very important basically concept of Amazon S3, which is versioning. So we can version our files in Amazon S3. It is enabled at the bucket level. So same key override will increment the version like 1.1, 1, 2, 3, 4 and many more. So it is best practice to version your buckets. Protect against unintended deletes. So ability to restore a version. Each rollback to previous version. So here are some key points to note it down. Any file that is not versioned prior to enabling versioning will have version null. So this can be asked in examination. Suspending versioning does not delete the previous version. Okay. So if you suspend versioning, then it does not delete the previous versions. So let's move further. Let's talk about S3 encryption for objects. So there are 4 methods of encrypting object in S3. First one is server-side encryption with S3. So here it encrypts the S3 object using key handled and managed by AWS. So SSC KMS. So basically KMS is stand for Key Management Services. So here we can use server-side encryption with key management system. It's leverage AWS Key Management Services to manage encryption keys. So sometimes it's called system, sometimes it's called service. So here it is a service. So sorry for that. So server-side encryption with server-side encryption client managed key. So when you want to manage your own encryption key, then we can use SSCC or we can use client-side encryption. Here we encrypt data at our site and we send it to the S3. So it is important to understand which one are adapted to which situation for the example question. So let's move further. Let's talk about SSC S3. So what is SSC S3? So basically it is server-side encryption where we can encrypt by key handled and managed by our Amazon S3. So this encryption is used when we want to ensure that key is handled by Amazon S3 only. So object is basically encrypted at server side and advanced encryption system 256 is used for encrypting the data or object. So must set header XAMZ server side encryption AES 256. So here is object and HTTPS plus header. Here our object plus S3 managed data key is result into encryption and that encrypted data is stored into our Amazon S3. So here encryption is done before storing the data into Amazon S3. So this point may be remembered. Let's talk about server-side encryption with key management services. So here when we are using SSC KMS, then our key are handled and managed by the key management services. So basically key management services have some advantages like user can control it and we can audit it by using cloud trial. Okay. So object is encrypted at server side and must set header is here XAMZ server side encryption and AWS KMS. Let's talk about the server side encryption with client key. So here server side encryption is using data key which is fully managed by the customer outside of the AWS. So Amazon S3 does not store the encryption key you provided. So here HTTP must be used and encryption key must provided in HTTP header for every HTTP request made. So here object are basically sent with the client side data key by using HTTPS only and data key in header. So here object is encrypted by using client provided data key and stored in Amazon S3. So let's move further. So let's talk about client side encryption. So here client libraries such as the Amazon S3 encryption client. So here basically encryption is done at client side, so it's called client side encryption. So here object plus client side data key is encrypted by the customer key at client side, and this encrypted object is go to the Amazon S3 and stored in Amazon S3. Here client must encrypt data themselves before sending to S3, and client must decrypt data themselves when retrieving from S3. So customer fully manage the keys and also encryption cycle. So remember this point and let's move further. Encryption in transit. So encryption can be implemented on transit data by using SSL or TLS. Basically SSL is secure circuit layer and TLS is transport layer security. So Amazon S3 exposes the HTTP endpoint, which is basically not encrypted. So HTTPS endpoint uses encryption in flight. So you are free or we are free to use the endpoint we want, but HTTPS is recommended. So most of clients would use the HTTPS endpoint by default. So HTTPS is mandatory for SSCC. So when we are using client server-side encryption with client provided key, then it is mandatory to make it HTTPS. Let's talk about S3 security. So here user-based security may include IAM policy, which API call should be allowed or which API call should be not allowed, which API call should be allowed for a specific user by the IAM console, by or from IAM console, and some or we can apply resource-based policy. Here we can apply user-based policy, and here we can apply resource-based policy like bucket policies, bucket-wide rules from the S3 console, or we can allow cross-account access, or we can basically set object access control list, or we can set bucket access control list. So object control list is widely used, and bucket access control is less common used. So here is some key point to note it down. An IAM principal can access an S3 object if and only if. So here the user IAM permission allow it or the resource policy allows it, and there is no any explicit deny. So if any explicit deny is present, then IAM principal cannot access that S3 object. Okay, so let's move further. So let's talk about some S3 object policies. So basically S3 bucket policy are JSON based documents which are basically contain resources, action, effect, principle. Like resources, buckets, and object action are may include set up API to allow or deny. Effect may be allow or deny. And principle, the account or user on which this policy is applied. And we can also use the S3 bucket for policy too. So like granting public access to the bucket and force object to be encrypted at upload, and we can grant access to another account. It's called cross account access. So here is a sample of a S3 bucket policy where you have a version where version is always set to 2012-10-17, and here is a statement, and statement may include like SID, which is also optional field. Here we can also write ID, but these are the optional field. So here effect is allowed and principle is asterisk, means everyone is allowed. So what is action? S3 get object. So anyone can get object from S3. So what is the resources? So resources name is something here like it may be resources your bucket name like ARN AWS S3 example bucket dot demo dot txt demo dot jpg or anything. So let's move further. Setting bucket for block public access. So block public access to bucket. Sorry for that. Let's talk about bucket setting for block public access. So we can block public access to bucket and object granted through by new access control list or any access control list. So or we can create new public bucket or access point policies. So we can block public and cross account access to bucket and object through any public bucket or access point policies. So this setting were created to prevent company data leaks. If you know your bucket should never be public, leave this on. So can be set at the account level. So some talks about the S3 security, others like networking. Networking is support VPC endpoint, for instance in VPC without www World Wide Web Internet. So logging and audit, we can use S3 access. Basically S3 access log can be stored in other S3 buckets, and API calls can be logged in AWS Cloud Trial. And user security, here we can enable MFA delete, MFA multi-factor authentication can be required in version bucket to delete object. And we can set pre-signed URL. So URL that are valid only for a limited time. X premium video services for logged in user can be distributed by using pre-signed URL. So let's talk about S3 website. So S3 can host static website and have them accessible on the World Wide Web. So the website URL will be bucket name .s3 website, AWS region and Amazon AWS.com, or it may be bucket name .s3 website .aws region and .amazon AWS.com. So if we get a 403 forbidden error, then make sure the bucket policy allows the public reads. So let's some hands on this S3. So let's move to our console. Let's quickly create a Amazon S3 bucket. So here we can click on create bucket, and here we can give a bucket name which must be a unique. Okay, so here I basically give a name to my bucket, basically ec.in, and we can select here AWS region. So it is by default set for me Mumbai AP South 1. So let's copy. We can also copy settings from existing S3 bucket. So here it is by default tick to block all public access. So if we want to access it publicly, so we must have to uncheck it, and here tick on I acknowledge that, and here we can enable or disable versioning. So here I enable versioning, and here we can enable or disable default encryption. So here server-side encryption is by default disabled. So we can also explore advanced setting, like advanced setting may include object locks, which is by default disabled, and we can click on create bucket. So my bucket tkj.in is created. So let's explore more. So here we can have basically 6 tabs. First one is object session, second one is properties. From here we can set basically properties related to like bucket versioning, tags, and many more. So here are the permissions for our object are basically here. Here I give the public access to my bucket, so that's why it is showing me off, and here are the matrices. So my bucket did not is newly created, that's why there is no matrix here. So here we can manage some lifecycle rule, and we can create some lifecycle rule, and here are the some access point. So here we can create access point. So let's move on objects, and we upload some object, like I upload so here we can click on add files, and here I upload my upload my image, which is basically a image. Where is, so this is my image one. So this is going to upload it. So tick here and click on upload. So my image is uploaded here successfully. So here we can publicly access this image. So if you want to access this image, then here click on close, and here we have to move like if I want to upload some more data, like to demonstrate some settings, like here we click on add files, and I upload a different image, which is basically rn.jpg. Why is this existed? So here rn.jpg is selected, and we can upload it. Okay, so here we uploaded the document. So here my both images are uploaded. So let's try to access this image. So here we can copy URL from here, and let's paste URL is here, and here what we get error, or what is error? Error code is access denied error. So we can solve this access denied error. So why this is giving access denied error? Because we did this object did not have public access permission, although we gave our bucket public access, but this object did not have publicly accessible. Okay, so that's why that is giving error. Where we click on this and copy URL and paste this URL here, my image is accessible here. So why this image is accessible, where is this image is not accessible by internet? Because of the permissions. Okay, so here we can click on actions and we can click on make public. So here we have to click on make public. So here I make this object public, so successfully edited public access is granted here, and now we can access this rn.jpg by using our URL. So here we go on this and here paste this URL and here our image is loaded. So now both two images are accessible by internet. So here two policy are play role. First one is bucket policy and second one is object policy. So here although we make our bucket public accessible, but we are not able to access this object publicly because here basically object policy come into play. So we must make to, if we want to access this images or this object publicly, then we must enable the public access on that object. So we can also use CloudFront to basically deliver these contents. So basically CloudFront is a content delivery network. We discuss it later on later slides. Okay, so here I discuss most of the options. So now we can here download it, open it, delete it. So many of the options are available here. So let's try. So I delete this object from here. So basically I deleted this object from here, and now here only one image is available in my S3 bucket. So here we can change permissions, like if you want to basically edit here, if we block all public access at bucket level. So here we have to click on confirm. So we confirm it, and now I try to access my object, my image.1.jpg, which is basically publicly accessible. So I paste and I try to access. What? I get error. What is the error? Error is access denied. So why? Because here bucket policy come into play. Although I set this object policy to public here, from here this object is make public, but here this object we cannot make it public. Why? Because failed to edit public access. Why this is failed to make it public? Because here we are giving explicit deny from bucket policy. So basically these are the rules. So first of all, to make it public accessible, like here we get a error. So if we want to access this object, so basically what we have to do, first of all we have to go on permissions, and here we have to edit and uncheck block all public access and save changes, and here type confirm and click on confirm. So now our basically bucket policy is giving permission to our object for public access. Now here we try to access this. So we press Ctrl R. Although we changed our bucket policy, but we are not able to access this object. Why? Question is why. So objects are not accessible due to the object, because object is not public. So we can make here public. So click on make public. So our object is now publicly accessible. So here we press Ctrl R, and first of all we have to close that window, and we have to use new incognito window, and here what we are getting access denied error continuously. So let's close and try to check what is the problem. So here we want to make it public. Successfully edited public access. Now close this, and here we have to copy URL, and after copying this URL we can paste it here, and here we are able to access our object. So let's close it, and we continue to next section of our slide, because if we go into more deep dive, then video is going to too large. So that's why I am skipping some hands-on, and also I am skipping some deep dive theories. Okay, so let's move on next slide. So let's try to understand about what is CORS. So basically CORS is stand for cross origin resource sharing. So this is basically an origin schema protocol which contain protocol host and port, like here. Web browser based mechanism to allow requests to other origins while visiting the main origin. Same origin like if we basically have the same like http example.com app1 and http example.com app2. Here origin is same, but here origin is different, because this is http example.com, but here http other.example.com. so they have different origins. So the request would not be fulfilled unless the other origin allow for the request using cross origin resource sharing headers. It may be set with access control allow origin parameter. So here is a diagram to depict the use cases of cross origin resource sharing. So here it is a origin www.example.com, and here is a web browser, and here we have pre-flight response like access control allow origin www.example.com, and access control allow method is get put delete. So basically sorry for that. Here we make a pre-flight request. It is a basically pre-flight response from our cross origin server. So basically when we basically request, so here option are option dot, here host is www.other.com, and here origin is www.example.com, and here is some cross origin like https www.other.com. so here if server is configured as a CORS cross origin resource for cross origin resource sharing, then it gave a pre-flight response, and then web browser can perform can basically make this request from the basically here from our origin server and can get response or can get the access of data. So basically CRS headers received previously allowed to the origin. So the web browser can now make the request to access that object. So here we have to only understand that here we make a request from the origin server to get the access of that object, and here we get a response, and on the basis of this response we can get access of that object. Okay. So basically S3 cross origin resource sharing can be enabled for all origins, or it can be enabled for only well-defined origins. So here our web browser gave a request to get index.html, and here our bucket.html enabled as a website gave the response, and now he requested for get copy.jpg and origin with origin header http bucket html s3 blah blah s3 website.eu west3 amazon aws.com, and here if our bucket asset cross origin enabled as a website, then here he get access and he can get the response of access control allow origin like this. Okay, so let's move further. So let us discuss some advanced topic in S3. So let's move on to next slide. So S3 MFA delete. So what is MFA? As we discussed earlier, MFA stands for multi-factor authentication. So MFA delete enforces user to generate a code on a device, usually a mobile phone or hardware, before doing important operation on S3. So to use MFA delete, enable versioning on the S3 bucket. So we will need MFA to permanently delete an object version. We can suspend versioning on the bucket. So we don't need MFA to enabling versioning, listing or deleting deleted versions. So only for the bucket owner, root account can enable or disable MFA delete. So MFA delete currently can only be enabled using the command line interface. So if you are using the AWS console to access the S3 bucket, then you are not able to enable the MFA delete option. Okay, so let's move further. So let us discuss the difference between the default encryption and bucket policy. Basically, bucket policy are evaluated before the default encryption. So what is the basic difference between both? So one way to force encryption is to use a bucket policy and refuse any API call to put an S3 object without encryption headers. And another way, we can use the default encryption option in S3 during the creation of that bucket. Here is an example of bucket policy, and here is a default bucket policy. Okay, so let's move on. So what is What is S3 access log? So basically, for editing purposes, we may want log access of S3 buckets. So any request made to S3 from any account, authorized or unauthorized, will be logged into another S3 bucket. So data can be analyzed using data analysis tool or Amazon Athena. Using the Amazon Athena, we will see later in this course. To check the log format in detail, you can visit on that website. Okay. So here a figure is given to understand the S3 access log. All the request and response is logged into that logging bucket. Okay, we can analyze it later by using Athena or any other data analysis tool. So there is a warning related to S3 access log. What is it? Do not set your logging bucket to be the monitored bucket. Why? It will create a logging loop and your bucket will grow in size exponentially, and this increases a huge cost. Okay, so do not try this here. So what is saying? If we put a object and also we log that in same bucket, like app bucket and logging bucket, if both are same, then it creates a logging loop. Okay, and it increases basically size. It increases size in exponential form. So please avoid this. So what is S3 replication? So basically, for using this feature, we have to must enable versioning in source and destination both. If we are using cross-region replication, then this line number 1 is a basic precondition to using CRR or SRR. So when we copy any object from a different, like if we replicate any bucket which belong from different region, like here we have a bucket in EU West 1 and here we have a bucket in US East 1. Like if we replicate any object or bucket itself, then you have to must enable the versioning to replicate the object from this region to this region, and also in both source and destination buckets. Bucket can be in different account and copying is asynchronous, so must give proper IAM permission to S3 to perform this operation. So cross-region replication use cases compliance like lower latency access replication across account. SRR use cases like log aggregation, live replication between production and test account. Let's move further. There is some important notes related to S3 replication. After activating, only new objects are replicated, not retroactive object. So when we enable S3 replication, then only new object which we created after enabling S3 replication can be only replicated. For delete operation, we can replicate delete marker from source to target. It is an optional setting. And for deletion with version ID, if it is not replicated, then we avoid malicious delete. There is no chaining of replication. Okay, so let's move further. Let's discuss the concept of pre-signed URLs. So we can generate pre-signed URL by using SDK or command line interface. For downloads, we can use CLI. For uploads further, we can use SDK. So it is valid for by default. It is valid for 3600 seconds. Okay, it's valid for 3600 seconds. So we can change timeout with expire in time by seconds argument. So user given a pre-signed URL inherit the permission of the person who generated the URL for get or put. There are some examples also given here. So if we want to allow only logged in users to download a premium video on our S3 bucket, then allow an ever-changing list of users to download files by generating URLs dynamically. So it's allowed temporarily a user to upload a file to a precise location in our bucket. So let's discuss S3 storage class. So Amazon S3 has different storage classes like Amazon S3 Standard. It is a general purpose storage class, and Amazon S3 Standard infrequent access like Amazon S3 Standard IA, and Amazon S3 One Zone infrequent access, and Amazon S3 Intelligent Tiering, Amazon Glacier Deep Archive. So Amazon S3 reduced redundancy storage for depreciated or omitted data. Okay. So here we talk about S3 Standard, which is a general purpose S3. So S3 Standard general purpose have high durability of object across multiple availability zones. So it's have basically 11 nines durability. How? 11? 2 to 4, 6, 8, 3, 11. So 11/9 durability. So if you store basically this huge number of objects. So if we store 1 million of objects with Amazon S3, so we can expect on an average basically loss of a single object once every 10,000 years. So it is highly durable, and its availability score is 99.99. so it can sustain 2 concurrent facility failures. Okay, so use cases may include big data analytics, mobile and gaming application, content distribution, and we can also store snapshot and many more use cases. And let us discuss S3 standard infrequent access. So it is suitable for data that is less frequently accessed but requires rapid access when needed. So it is highly durable, and objects are replicated on across multiple availability zones, and it's have 99.9% availability. It is low cost compared to Amazon S3 standard, and it can sustain 2 concurrent faculty failure. Okay, So use cases like as a data store for disaster recovery, backups, and many more. So S3 one zone infrequent access. So it is the same as infrequent access, but data is stored in only single availability zone. It is highly durable, uh, but let data when any disaster is occurred, then data may be lost or destroyed. It has 99.5% of availability. So low latency and high throughput performance. It supports SSL for data at transit and encryption at rest. So low cost compared to infrequent access by 20%. Use cases may include storing secondary backup copies, on-premises data, or storing data you can recreate. Okay, let's move further. So let's discuss about S3 intelligent tiling. So it is have same low latency and high throughput performance as S3 standard, and some small monthly monitoring and auto tiering fee. So it's automatically move object between two access tier based on changing access patterns. It's designed for highly durability of object across multiple availability zones. It is resilient against events that impact an entire availability zone. So it is designed for 99.9% availability over a given year. So let's discuss about Amazon Glacier. So Amazon Glacier is low cost object storage means of archiving or backup. Data is retained for a longer term, like it's may be stored for 10 years, for 2 years or 3 years. So alternative to a on-premise magnetic tape storage. So average annual durability is 99.9999 so on. So cost per storage per month is US dollar 0.004 per GB plus retrieval cost. So each item in Glacier is called archive. We can store up to 40 terabytes of archive. Archive are stored in vaults. So Amazon Glacier and Glacier Deep Archive. So Amazon Glacier have basically three retrieval options. First one is expedited, where data may be available in 1 to 5 minutes, and in standard data is basically accessible within 3 to 5 hours, and for bulk retrieval data is available within 5 to 12 hours, and minimum storage duration for Amazon Glacier is 90 days. Amazon Glacier Deep Archive. So here if we store for long-term storage, then it's cheaper. So standard data retrieval time is 12 hours, and for bulk retrieval we have to wait for 48 hours. Minimum storage duration is up to 100. Minimum storage duration is 180 days. So here is basically a C storage class comparison. So you can remember it and compare this chart, and always consider this chart, because in exam many questions may be raised from S3 storage class. Okay, so let's discuss about S3 lifecycle rules. So here, what is transaction action? So basically, transaction action define when objects are transitioned to another storage class, like moving object to standard IA class after creation of 60 days. Move to Glacier for archive after 6 months. Expiration actions like configuring object to expire or delete after some time. So we can access log file can be set to delete after a 365 days. Can be used to delete old version of file if versioning is enabled. Can be used to delete incomplete multi-part uploads. Rule can be created for a certain prefix, or rule can be created for certain object tags. So let's move to next slide. So let us discuss a scenario of S3 lifecycle rule. Our application on EC2 creates images, thumbnails after profile photos are uploaded to Amazon S3. These thumbnails can be easily recreated and only need to be kept for 45 days. The source image should be able to be immediately retrieved for these 45 days. And afterwards, the user can wait up to 6 hours. How would you design this? So first we have let's discuss this scenario. So here we can conclude S3 source images can be on standard with lifecycle configuration to transition them to Glacier after 45 days. How we conclude this conclusion? Because our application on EC2 create images, thumbnails after profile photos are uploaded to Amazon S3. So these thumbnails can be easily recreated and only need to be kept for 45 days. So after 45 days we can transit them into Glacier. So the source images should be able to be immediately retrieved for these 45 days, and afterward the user can wait up to 6 hours. How would you design this? So basically, also if you want to optimize cost, then we can upload it into S3. Thumbnails can be on one zone infrequent access with lifecycle configuration to expire them or delete them after 45 days. So it may be an exam question. So let's move further. So here is a scenario 2 where a rule in our company states that you should be able to recover your deleted S3 object immediately after for 15 days, although this may happen rarely. After this time and for up to 365 days, deleted objects should be recoverable within 48 hours. So what should do in this scenario? So in this scenario, we need to enable S3 versioning in order to have object versions so that deleted objects are in fact hidden by a delete marker and can be recovered. Okay, and you can also transit this into non-current versions of the object to S3 IA. And also we can transition afterward this non-current version to deep archive. Okay, so let's move further. Let's talk about S3 analytics, storage class analysis. So basically we can set up S3 analytics to help determine when to transition object from standard to standard infrequent access. Does not work for one zone, IA or Glacier. So report is basically updated daily and takes about 24 hours to 48 hours to first start. So it is good first step to put together lifecycle rule or improve them. So what are the basic S3 baseline performance? So Amazon S3 automatically scales to high request rate, latency up to 100 to 200 microseconds. Your application can achieve at least 3500 put, copy, post or delete and 5500 get head request per second per prefix in bucket. And there are no limits to the number of prefixes in bucket. Okay, like example of object path or prefixes. So this is a object path and here is a prefix. So these are the basically prefix and this is the complete object path. So if we spread reads across all four prefixes evenly, we can achieve 22,000 requests per second for get and head. So let's move further. What are the basically limitation of KMS for S3? So if we use SSC KMS, we may be impacted by the KMS limits. So when we upload, it calls the generate data key KMS API. When we download it, it's called the decrypt KMS API and count towards the KMS quota per second. It is a request per second based on the regions. So you can request a quota increase using the service quota console. So basic diagram is here given. Let's try to understand S3 performance. So here it is a multi-part upload. It is recommended for files having greater than 100 MB size and it is must to use multi-part upload file size greater than 5 GB. It can help parallelize upload, so it overall increases the speed of transfer. So here big file is divided into multiple parts and it's parallelly upload to Amazon S3 and then binded up. So let's learn about S3 transfer acceleration. So it increases the transfer speed by transferring file to an AWS edge location, which will forward the data to S3 bucket in the target region. So it is compatible with multi-part upload. So if you want to transfer use S3 transfer acceleration, so it can be, we can use multi-part and S3 transfer acceleration together to speed up to increase our upload speed. So let's talk about S3 byte range fetches. So when parallelized gets by requesting specific byte range and it is better resilience in case of failure. It can be used for speed up downloads and it can be used to retrieve only partial data, for example the head of a file, like byte range request for header first access byte. So let's move further. S3 select and Glacier select. So we can retrieve list data using SQL by performing server-side filtering. It can filter by rows and column. It is a simple SQL statement. So less network transfer, less CPU cost at client side. So here is the diagram is given. So let's move further. Let's try to understand S3 event notifications. So So basically S3 event notification. Here are four types of S3 event notification. When we create, when object is created, when object is removed, when object is restored, or when object is replicated, then it can basically trigger an event. Object name filtering possible like *jpg use cases. We can use it to generate thumbnails of images uploaded to S3, or we can create as many S3 events as desired. So S3 events notification typically deliver events in seconds but can sometimes take a minute or longer. If two writes are made to a single non-urgent object at the same time, it is possible that only a single event notification will be sent. If you want to ensure that an event notification is sent for every successful write, you can enable versioning on your bucket. So here each events Amazon S3, it can either send to SNS, SQS or Lambda functions. So let's move further. What is S3 requester page? Basically, in general, bucket owners pay for all Amazon S3 storage and data transfer cost associated with their bucket. With requester page bucket, the requester instead of the bucket owner pays the cost of the request and the data downloaded from the bucket. So it's helpful when you want to share large dataset with other accounts. The requester must be authenticated in AWS and it cannot be anonymous. Like from this diagram you can clearly understand. Here owner pay storage cost and owner also pay networking cost. Requester does not pay any cost, but in requester page bucket owner pay only storage cost but requester pay networking cost for downloading data. Okay, let's move to the next slide. Let's talk about AWS Athena. So basically Athena is a serverless service to perform analytics directly against S3 files. Here we can use SQL language to query the files. Has a JDBC or ODBC driver, basically Java database connectivity and object basically open database connectivity driver. It charges per query and amount of data scanned. It supports CSV, JSON, ORC, Avero, and Paraquet built on Presto. So use cases may include business intelligence, analytics, reporting, analyze, and query. By using this Athena, we can analyze VPC flow logs, elastic load balancer log, collateral logs, etc. So here is example. If it asks about tool and who can analyze data directly on S3, then here answer is use Athena. So let's discuss about Glacier Vault Lock. So basically it is adopt a VAR like write once and read many more times model. So it's lock the policy for future edit and no longer can change. It's helpful for compliance and data retentions. Here object is moved into vault lock policy, so object cannot be deleted. So let's try to understand S3 object log. Here to use this feature versioning must be enabled. So it's also adopt the write once read many model. It's basically block an object version deletion for a specified amount of time. Here object retention uh, period specify a fixed period, and legal hold specify the same protection with no expiry date. So basically let's discuss about modes. Here are basically two modes are used. First one is a governance mode. User cannot overwrite or delete an object version or after its lock setting unless they have a special permission. Second one is compilation mode. Here a protected object version cannot be overwritten or deleted by any user, including the root user. In our AWS account, when an object is logged in compliance mode, its retention mode cannot be changed and its retention period cannot be shortened. Let's move further. Let's discuss about a very important topic, which is a CloudFront. Basically, AWS CloudFront is a content delivery network. It improves the read performance by using the cache known as edge location. Here, until this making this video, preparing this PPT, we have only 216 point of presence globally, but this number can be changed. So please verify by using AWS global infrastructure. So here CloudFront have default DDoS protection, and it has integration with Shield, and it's has a very strong integration with AWS Web Application Firewall, and it can expose external HTTPS and can talk to internal HTTPS backends. So let's talk about CloudFront origins. So when we talk about S3 bucket, for distributing files and caching them at the edge locations, we use origins. For enhancing security with CloudFront origin as its identity, here we use the concept of origins, and also for CloudFront can be used as an ingress to upload files to S3, and also it can be used for egress for downloading from S3. So here let's talk about custom origin, which is based on basically hypertext transfer protocol. First one is application load balancer, second one is EC2 instance, third one is S3 website. Must first enable the bucket as a static S3 website. So any HTTP backend we want. Let's try to understand CloudFront at a high level. So basically here, what do you understand by seeing this diagram? Let's try to explain. So here I am explaining this. So here client make a request with some URL, and here are some user agent section, like this URL is made with Mozilla Firefox browser. So this is, and this is basically host name, and this is accepted encoding. So basically this packet is basically forward by our client to the edge location, and then edge location forward this to basically S3 origin. So here what happened, S3 origin gave some response to our edge locations, and then edge location make a cache record of that response, and then he basically give back response to the client. So next time client request the packet with the same headers configuration, then here each location can give response by using her cache, local cache. So this overall increases the basically throughput and minimizes the latency of the overall network, and it also decreases the load of our S3 origin or HTTP origin. So let's move on next slide. So here we talk about S3 as an origin. So here maybe our S3 bucket can be connected with many of the edge location, like edge location located in Los Angeles, edge location in Sao Paulo, and edge location in Mumbai, edge location in Melbourne. So here many of the user publicly access this edge location, and they are basically communicating with S3 bucket. So here our communication is goes through this edge location, and this edge location make a local copy of our frequently used or latest used responses. So that's why they are giving very low latency experience to our users. Although our origin S3 buckets is located at one place, but our client are getting here very low latency. So here our S3 bucket is connected with OAI plus with S3 bucket policy. So basically here we verify the origin access identity of every basically request made to our S3 bucket. So let's move to next slide. So let's try to understand application load balancer or EC2 as an origin. So here user make some request to from our edge location, and each location then forward that request to our EC2 instances, which are in must be in public domain. So they are in public basically subnets. So here our edge location directly communicate with that basically these instances. So here we will allow the public IP of edge locations in our security group, so they can communicate. But if we are configuring the application load balancer as an origin, then what will be the architecture we follow? So here we user make request from edge location, then edge location can communicate with basically our load balancer. Here security group of load balancer allow the public IP of edge location, and then application load balancer basically make request from EC2 instances. Basically they transfer that request to EC2 instances, and here in security group of our EC2 instances we have allow only the traffic from inbound traffic from load balancer. So that's why it's overall increases our security, and it's basically balances our load between our EC2 groups, and here application load balancer must be in the public subnet. Okay, let's move on next slide. So let's try to understand about what is CloudFront geo restriction. So basically by using CloudFront geo restriction we can restrict who can access our distributions. So we can either whitelist or blacklist someone's IP addresses or some ranges of IP addresses. So here when we what is whitelist? So when we allow our users to access our content only if they are in one of the countries on in list of approved countries. Like we want to allow to access our CloudFront for Indian origin request. Like we want to only deliver our content to for India countries users. So here we only whitelist the IP of India, basically Indian IPs. Okay, and if you want to blacklist, and so what is blacklist? If you want to prevent our users from accessing our content if they are in one of the countries, like if they are in Pakistan, then we banned basically all the IPs are related to Pakistan. So no one can able to access our CloudFront, which are basically geolocated within the Pakistan. Although we know we can use VPN to access and to overcome from these instructions, these basically restrictions. So the country can be determined by using a third-party geo IP databases, and use cases may be include like copyright laws to control access to content. So let's move on new slide. So let's try to understand the difference between CloudFront and S3 cross-region replication. So what is basic CloudFront do? Basically CloudFront is a global edge network, and file are cached for time to live, maybe one day. So time to live is basically 300 seconds, but it may be one day. So here we can get the basically content which is older 1 day older. So it is only great for static content that must be available everywhere. So let's try to understand what is cross-region replication. So it must be set up for each region we want replication to happen. So it must be manually set up in each region. So files are uploaded in near real time. So here we don't get any old record of our content. So it is only read only. Here we cannot write. Here we create this S3 cross-region replication is great for dynamic content that need to be available at low latency in few regions. So let's move on new slide. Let's we make some hands-on on our CloudFront. So here we will create an S3 bucket, and we will create a CloudFront distribution, and we will create an origin access identity, and we will limit the S3 bucket to be accessed only using this identity. So let's move on our console. So let's search here CloudFront, and here we search for CloudFront, and basically here my CloudFront front page is not opening because I am logged out. So here I have to log in first. So I am trying to log in first. I have to enter my MFA code because I have enabled the two-factor authentication in my account. That's why I have to enter my MFA. So here I am logging back into my account. So here we can create a cloud front. So here we click on create distribution. So here we can give origin name, like here we gave my demo cloud front. Okay, and first of all I did not, so I have created a S3 bucket. So you must create a S3 bucket first, as I show the hands-on on S3 buckets, so you can follow those steps to create S3 bucket. So here I am going to follow HTTP only protocol, and here port is 80, and here this is an optional field, so I am not entering something here. So enable origin shield, I say no. So here are the some basically default cache behavior, and here our object is compressed automatically IT cache, and here basically our viewer protocol policy is HTTP and HTTPS, so we can force to redirect HTTP to HTTPS. Here we can use allowed methods, like we can use get head or get head option method, or get ahead option put post patch delete method in our header. So restrict viewer access, yes, I want to restrict it because I want to only distribute our cloud front, our bucket access by using only cloud front URL. So basically you can check it yes if you want it. If you did not want, then we can simply click on no. So here we have to make a cache key and origin request. So here we can go to legacy, we can check either in cache policy and origin request policy, and either we can make legacy cache setting. So here we are making cache policy and origin access request recommended. So here we can create a policy. So let's create a policy. So here we give the policy name my demo policy, and description is always optional, and minimum TTL is 1 and maximum TTL is set here. So I am going to use default setting and click on here create. So this is created. Now come to the CloudFront. Now here we can refresh it, and now our policy is set. So origin, we can here also set origin request policy. It is optional, but we can create policy. So here I basically create origin policy. So this give my demo origin policy, and also here I click on create. So my demo policy is created. So I can basically here refresh it. So here I want to use only my demo origin policy. So here are some managed policies also given, like cross S3 origin policy and all viewer policy, and user agent referrer headers, and many more. So I choose my created policy, and here we can also check this if we require. I did not use any of these settings, so we can also choose web ACL. So I am choosing no any ACL. Click on create distribution. So creating distribution can take some time. here the parameter origin name must be a domain name. So here we are making some mistake, so let's try to diagnose it. So here we basically it says the parameter origin name must be a domain name. So here in first section we have to enter basically a domain. Like here we basically when we create a S3 bucket, like here this is my basically S3 bucket which is basically I created when I am giving hands-on lab on Amazon S3. So by following that procedure you can also create this. So let's move further. So here I selected basically my take is a S3 bucket as a bucket domain. So I think this issue may be resolved after selecting this. So let's create distribution. So here our CloudFront distribution is successfully created. So this is now in deploying stage. So it's take up to 2 to 3 hours time to basically running and up. So let's wait for its running stage. So here we go to CloudFront. Here basically this CloudFront is enabled, and basically this is in deploying stage. So let's wait for it. So here status is enabled, but it is now in deploying stage. So basically we have to basically wait for it. So guys, this status of our distribution is now enabled, but although our status is enabled, but we are not able to access this S3 bucket or this S3 basically because S3 bucket, because it's take up to 24 hours to 48 hours to update all of CloudFront's its location. So here we cannot wait for 2 days to basically enable this CloudFront. So here what happens if we are trying to access to our basically CloudFront distribution. So here we can access it by using this distribution domain name. Then we can open it in new incognito window, and it's giving the access denied error. Why this is giving access denied error? Because all the its location of CloudFront is not updated the record. So it can take up to 24 to 48 hours of time. So basically after this time we are able to access this CloudFront domain. Okay, so I am disabling it because it is not comes into free tier. We have to pay charges for it, so I am disabling it. My only purpose here to demonstrate how to create this CloudFront distribution. So let's move to next slide. So let's talk about the CloudFront signed URL. So basically if we want to distribute paid or shared content to premium users over the world, then we can use CloudFront signed URL or cookie feature. We attach a policy with our URL. Basically, it include URL expiration. It include IP ranges to access that data from, and it also contains the trusted signers, like which AWS account can create signed URLs. So basically, how long should this URL are valid for? So basically, shared content like movie, music, we can make it short. URL is valid for only for few minutes. Like if we are sharing private content to our private users, then we can make it for last basically 1 to 2 years based on our requirement. So here signed URL are only give access to individual file or one signed URL per file, whereas if we are using signed cookies, then we can give access to multiple files by one signed cookies. So here one signed cookies work for many of the files. So please remember these both points. What is signed URL? Basically, by using signed URL, we can access only individual file, like one site URL per file. Whereas if we are using signed cookies, then we can give access to multiple files. Here, one signed URL cookies for many files. So let's move further. Here, CloudFront signed URL diagram is illustrated here. So here, client basically, first of all, client request from this application. Okay, this basically make authentication plus authorization by using any authorization, like it can use single sign-on authorization SSO, or it can use Google authentication, or many more options are also available for. Basically here client login in our application, and our application return a signed URL to our client. Here, by using this signed URL, our client can access the Amazon CloudFront. And here Amazon CloudFront basically transfer that client request by verifying the origin access identity to access that object in Amazon S3. Then he returned that object, which is basically requested by the user to its location. Here our CloudFront its location, make it copy it in our cache, in her cache, and they can respond to that client. So this is the very simple diagram to illustrate the CloudFront signed URL. So let's move further. So what is the basically difference between CloudFront signed URL and S3 pre-signed URL? So if we talk about the CloudFront signed URL, then it allow access to a path no matter the origin. Okay, it's provide a key pair for only the root, which key pair can be managed by only the root user, and it can filter by using IP, path, date, and expiration, and it can leverage the caching features. Okay, and what is then S3 pre-signed URL? It issue a request as the person who pre-signed the URL. So it uses the IAM key for the signing to the principal. Like principal may be any user. Okay. So S3 pre-signed URL has only limited lifetime. Let's talk about CloudFront pricing. So basically CloudFront edge location are all around the world. So cost of data out per edge location varies. So here a diagram is given. Basically, if we talk about United States, then here cost is lower, and if we talk about India, then here cost is highest. So basically I belong from India, then here if you are using CloudFront in the India, then you are going to pay more cost than US, Canada or Mexican users. So let's move further. So basically let's talk about the CloudFront price classes. So we can reduce the number of edge location for cost reduction. So these price classes may be classes for best performance and class 200 for most regions but exclude the most expensive regions. So if we talk about price class 100, then it's contain only at least expensive region. So we can compare these price classes. Okay, so let's move further. So basically this is the diagram which illustrating the basically CloudFront price classes. So here you can see. So let's move further. So let's talk about CloudFront multiple origin. So to route to different kind of origin based on the content type, so we can specify the path pattern, like if we follow the images slash images slash asterisk, if we are follow path API slash asterisk, if you follow path slash dot asterisk, then here our cache behavior may be different for this different path. So like here if we are using if we have like this path, then we can directly access S3 bucket. Otherwise if we have this path, then basically go to our basically request go to the application load balancer. So basically this path is defined, this path define the behavior of our cache. So let's move further. So let's talk about the CloudFront origin groups. So basically if we want to increase and we want to minimize the failover, then we can use CloudFront origin groups. So it's used for to increase the high availability and to manage failover. So origin group are one primary and have one primary and one secondary origin. If the primary origin fails, then secondary origin is used. Like in the given diagram, here client make request from Amazon CloudFront, and here request is transferred to our origin A, and here it's respond with some error status code, like our primary origin is goes down. Then here our CloudFront basically try the same request with origin B, and it responds with OK status method status code. Then he can basically communicate further from origin B. So it's basically ensures the high availability. And here we can also use these origin groups with our buckets. Like here, if our client make a request from our Amazon CloudFront, and so Amazon CloudFront send request to origin A, because origin A is primary origin, and if basically primary origin respond with error status code, then our CloudFront tries the same request to origin B, and if origin B give response with OK status code, then our basically Amazon CloudFront fetch data from origin B and give response to the client. So basically S3 plus CloudFront minus region level. So it's we can use here S3 and basically CloudFront to ensure high availability and to manage failures. Okay, so let's move further. Let's talk about CloudFront field level encryption. So basically field level encryption is used to protect user sensitive information through application stack. So it adds an additional layer of security along with hypertext transfer protocol security. So it secures the sensitive information encrypted at the edge close to the user. So it uses asymmetric encryption. Here both keys are different. So what is the basically use cases of field level encryption? So by using field level encryption, we can specify set of fields in post request that we want to be encrypted up to 10 fields. So basically it specifies the public key to encrypt them. So here a diagram is given to illustrate the basically concept of field level encryption. So here our client make a request, and here he has he make a post request, like here URL is something as submit http/1.1 and host is any example.com, and here we have two field, and here user want third field to be encrypted. So by using public key at edge location, we can encrypt the field 3. So we can basically encrypt this sensitive field and we transfer it over HTTPS to Amazon CloudFront. So basically here encryption is done at closest edge location to the user. So here our only sensitive field is encrypted, not all fields are encrypted. So here we can basically, if we are using field level encryption, then we can encrypt basically only some specified and sensitive fields, and then we can transfer that request to Amazon CloudFront, and then this request is goes to basically our origin servers, like it can go to application load balancer, or then request is transferred to our web server, and here it is decrypted by using the private key. Okay, so let's move further.